most of the time we are dealing with training related to halal testing and Toiban testing as well. Beside of testing, most of the time we conduct training. All this while before COVID, we conduct training face to face, especially that we're dealing with some instrumentation that we have. Okay. But since the condition of COVID is still prevalent nowadays, so we stick to this method. So thank you again, everyone, for joining this workshop. Okay, so let me share the slide as well. Okay, so for this workshop, okay, we have been assisted by Sister Alifa as the science officer, together with Brother Nizam is the lab assistant. Okay, so for this topic, actually this multivariate data analysis in food studies has been conducted, I think, this year. But this one, after the completion of the first session, we received a few requests because some of the participants cannot join, potential participants cannot join because of their time constraint. So we we conduct a new, the second session of multivariate data analysis, and Alhamdulillah, we receive a lot invitees, yeah, and participants joining. Okay. So, kejap ya. Sini ada, kita panggil apa? Boleh share lah. Okay. Terima kasih kerana join. So for this workshop, it is bilingual. Tuan-tuan boleh nak bertanya dalam bahasa Melayu ataupun bahasa Inggeris, terpulang. Ya, so kita akan assist lah mana-mana pertanyaan. Okay, so saya punya recommendation, cadangan saya lebih baik kalau tuan-tuan boleh type di bahagian chat box, ya, supaya senang boleh Sister Alifa akan bacakan. Ataupun jika betul-betul nak tanya, boleh saja tekan button yang raise hand tu. Okay, so we can assist you on answering any issues lah. Okay, post of this workshop, in our previous dealing, kita deal juga dengan participant yang bawa their own data, and then we will especially I myself will assist the participant lah, on how to deal with their data. Okay, so for today, we are going to have a workshop starting at 9 until 1 p.m. And tomorrow we will continue starting at the same time, 9 a.m. to 1 p.m. This way of doing it is to avoid kita panggil apa penat lah, because we are dealing with so much of data, and for some of us might be multivariate data analysis is their first time appearing in your mind, or sometimes people learn it by reading but never experience how to analyze the data itself. So dia boleh menjadi satu benda yang memenatkan fikiran lah, sebab tuan-tuan perlu baca, perlu faham, dan juga perlu nak mahir bagaimana nak menggunakan software-software lah. Okay, so for this today, let me share. Okay, boleh baru nak buka. Okay, so this is our slide. Oh, dia tak nampak kat sini sebab kita kena share baru kan. Saya share dulu. We share first our screen. Okay, so if you check in your email, there is invitation by Sister Alifa related what is the folder for our workshop. So you can get this folder named as Second 2001 Multivariate Data Analysis in Food Studies. Nampak yang ni? Ini dah boleh buka dah? Belum. Okay, so if you see this folder, so in that folder there is there are a few folders. There are two folders and a few files. So the first file that we are going to see is how to install XLStat. So this is the software that we are going to use, and then we also have the tentative program, and then for the note, the nota that we are going to follow through throughout these 2 days workshop is this one, multivariate Microsoft PowerPoint draft multivariate data analysis. And then for all the data that we are going to use, for today is the number six dot data for multivariate data analysis in food studies. Those numbers that you saw in that folder name is because how I arrange the data in my laptop. So I don't want to change the name. Afraid that I might be facing difficulties on finding the folder. So I just copy the whole name of the folder lah. Okay. And then the last folder is references, which is you can refer some of the related references related to the multivariate data analysis, and some of them are related to my publication. So if you go through of some of this paper, I will sharing with you the similar flow of idea according to the paper that I wrote. Okay. Okay, sila boleh duduk. Okay. Kalau ada soalan boleh tanya ya. Okay. Sekejap kena buka file dulu. Okay, so I am sharing this our PowerPoint. So this is the note that we are going to follow through for the whole 2 days of this workshop. Okay. Ini nampak? Nampak? Yeah. Okay. So this is the okay. Yeah. So this is the title that we are going to follow through for the whole 2 week. 2 days. Multivariate data analysis in food studies 2.0. Okay, this is the second time of the sharing. Yeah. So for this one, why I start to share this topic. Okay, so let me share the experience. So when I did my PhD in UPM, I face or get some advice from the supervisors because we have lots of supervisors in universities. So most of them, they are only focusing on statistical analysis related to ANOVA, analysis of variance to make a comparison between parameters or even between treatment that we gave to the sample analysis. Okay, unfortunately, before I joined academia, before I conduct my PhD, I was working as the registered chemist for the Department of Chemistry Malaysia, where this laboratory is a government laboratory which is aged more than 100 years, and they have millions of data. Yeah, so from there we conducting or learn about how to deal with multivariate data analysis, most multivariables to predict the condition related to environmental impact on our Malaysian shoreline, for example. So previously I deal with oil spill analysis, where we managed to identify the culprit of any company who make a oil spill to our water shore. So by using this multivariate data analysis, we can track who is the culprit. So by that time, when I joined the academia, I found that most of studies related to food, they try to focus more on single parameter, and then this single parameter really focus on univariate data analysis, which is ANOVA, for example. So because of this, I think we can learn more because with the advancements of technologies, with the more data that we have worldwide and even in Malaysia itself, we can use this multivariate data analysis approach to solve many problems and then to assist us in making any decision. Okay, so in this, so because of that, I try to propose this multivariate data analysis lah for our study. Yeah. So lots of people learn about multivariate data analysis using different kind of softwares. Yeah. So we have Unscrambler, we have SAS, we have design of expert, for example. But for now, I'm sharing you on using XLStat. Okay, why XLStat? It's not saying that it is the best, yeah, but I'm quite familiar with XLStat when I working as a registered chemist, and XLStat is one of the software which can be installed to our Microsoft Excel. Yeah, if you very familiar with other softwares, if you want to use the software itself, you need to import the software, the Excel file to the software, and then you can conduct the multivariate data analysis. However, by using this Excel set, we can simply open up our data using Excel and carry out the multivariate data analysis using the Excel itself. So kita tak perlu nak import file masuk ke mana-mana folder lah, mana-mana software lah. So dalam ni XLStat ni dia akan embedded lah, dia akan attach to our Excel. Okay. So untuk this slide, we just sharing apa yang kita akan belajar for this whole day. Okay, so untuk hari ni kita akan belajar berkenaan first one, there is part A, principle of component analysis in food studies. Kemudian kita akan rehat sekejap pukul 10. And then sambung semula dengan hands-on of principal component analysis in food studies. Hands-on ni maksud dia is we are going to analyze the data that we share, yang saya ada bagi dalam folder, so everybody can try. And then kita akan rehat sekejap, and then kita akan sambung dengan cluster analysis in food studies. Kemudian kita akan break, sambung sekejap, kita ada hands-on cluster analysis in food studies. Okay, before the part A actually, kita akan belajar sikit sahaja berkenaan the prerequisite requirement of multivariate data analysis. So if you see, kita akan belajar for the 2 days. Within the 2 days is PCA, Principal Component Analysis, Cluster Analysis. Tomorrow we are going to learn about discriminant analysis and multiple linear regression in food studies. But before we are going to embark to this multivariate data analysis, there are some data prerequisite, which is kita perlu buat some treatment lah, some data treatment. So we will learn a little bit this morning before going to the principal component analysis. So this is our 2 days outline lah. Okay, so for this one,
excuse me, Dr. Shirwan.
Yeah.
Your slide is not moving.
Oh really? Sekejap ya.
Maybe for slide presentation view.
Sekejap ya. Kalau yang ni nampak tak? Gerak tak?
Gerak. Sekarang introduction slide, is it?
Gerak okay.
Yes.
So kalau gerak okey lah. Thank you Sister Arifah. Yang ni kita nak tolong inform because previous workshop saya been kicked out from the Google Meet. Okay. So for now we are going to start with introduction. The first thing is installing the XLStat software. Ini bergerak Sister Arifah, nampak ya?
Yes, nampak.
Okay.
Instant.
Okay, so you can go to this one, https www.xlstat.com, and then you can click to this XLStat, kita boleh install lah. Okay, after you go to this website, okay, you akan sampai to this page. So please click this one, try now. Try now. You try to click this one, and then you can install lah. Okay. We will bring you to another web page, which is this one, XLStat by Edinsoft. So dia ada a few software lah, XLWiz lah, XL Optim, and then Zenplot. But what you call that one? Kita panggil the main software that we are going to use underneath by this Edinsoft manufacturer or software developer is XLStat lah. This XLWiz, XL Optim, and Zenplot, all of these are the kita panggil apa? Additional, but I never try this one. Okay, so you can try this one. So this XLStat that I propose to you to install is just a trial version. Which is if you install, it will give you 14 days trial, and then but you can access the whole features that they have. Okay. So you will go and then they will bring you to this page. 14 day, you can see there. 14-day free trial XLStat by Edinsoft. Okay, so you just choose this one. You nak pakai your Windows OS or you are using Mac, you can download. And then afterward, they will bring you, this is the direction or the command, install XLStat, and then you can activate the XLStat later, but you need to fill in some of the form lah macam ni. Okay. Okay. And then if you already installed the XLStat, you can open your Excel and then you can get this tab here. They will name as XLStat. You just click that XLStat. So dia akan buka lah. But for your information, the one that you install is the latest one. Unfortunately for myself, the one that I have is the 2019 version. Maybe a little bit or slightly different in terms of features lah, but it's not so much difference. And then don't worry about this workshop input. If you cannot follow, you can ask question, or even you really need time to understand or the flow of that analysis using the software. All of our workshop is recorded, so we will provide the recording. I will upload into my YouTube later, and I will provide the link so that you can follow through together with the data that we have provided. Okay, so boleh refer, jangan risau about this flow lah. The most important part that I'm looking for to all the participants, you know how to interpret the data. Issue dia sekarang, the way that we learn in our school or in our degree, when we talk about statistical analysis, the one that we have been emphasized is how to memorize the formula. But unfortunately, when we going to upgrade ourselves into our masters, into our PhD, into our postdoc, for example, most of the time, those that we are going to really face the challenge is how to interpret the data. So for this workshop, I'm not focusing on what you should click, but I will show how. But my focus is if you get a result, how you can interpret the data lah. Okay. So this is the software of XLStat. Okay. So I'm hoping that everyone, do you need time to install or have you installed this one earlier? Participant semua ada yang dah install ke ataupun yang belum install?
Saya dah install dah.
Do you need time to install? Anybody who never or haven't installed yet? Perlu masa ke nak install? Kalau tak, saya hold sekejap dalam 5 minit, allow you to install. Boleh? Boleh Okay, kalau macam tu macam ni, even though mungkin you ada install, ada yang belum, so I just allow, can we start at 9:30? Kita benarkan masa untuk you install, and then 9:30 kita akan continue with the rest of the PowerPoint workshop Okay. Kita bagi masa sikit untuk you, siapa yang boleh install lah. Okay, I think we have allowed the participant to install the software. Yeah. So we will continue with the uh, PowerPoint. So kenapa multivariate? Why multivariate? Okay. So all this while, yeah, let me share. When you read any publication related to multivariate analysis, yeah, the one that which is the advanced field currently is the environmental studies. So this is what I found when I work as a chemist in as a registered chemist in Jabatan Kimia, where our multivariate data analysis in environmental study have been in an advanced level compared to food. Yeah. So when I conduct my PhD in antimicrobial studies in food, and then I face that, okay, we still stuck with the univariate. Yeah. So because of that, kita pergi to multivariate to introduce this multivariate analysis to food studies as well. So you can see here, I give an example. This is an example of amino acids. Yeah. Bovine, B is for bovine. Yeah. Amino acid untuk lembu lah. Yeah. Sometimes we took from the lembu punya daging, or even sometimes from the tulang lah. Bovine skin. Kita panggil apa, kulit pun ada. Okay. So from this bovine we analyze amino acids. Yeah. So dekat sini tuan-tuan boleh lihat 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So kita ada 13. We have 13 amino acid. Actually, when the analysis being carried out, we analyze 17 amino acid. But for the purpose of just sharing in our workshop, so saya hanya copy paste 13 amino acid saja, ya, to show you that we have multiple variable, multi variable. That's why we call it multivariate lah. Kita ada banyak parameter, kita ada banyak variable. So that's why we call it multivariable lah, and then multivariate. So when you have multiple variables for one sample, you want to know relationship among the variables. Contohnya, we have lots of this amino acid, histidine, serine, arginine, glycine, sampailah methionine. Okay, but we want to know what are the relationship of this amino acid in the bovine gelatin itself. Ni amino acid B ni is bovine, but we analyzing bovine gelatin. So for example, in INHAT, we analyze or we offer services for halal testing. So what we did, sometimes we conduct PCR technique for DNA analysis. Yeah? Sometimes for those product itself, we try to extend using other methods lah. So one of the method is using HPLC. So using this HPLC, we can analyze amino acids in the gelatin. For halal testing, gelatin is one of the critical ingredient lah. So instead of just not focusing to DNA alone, since INHAT also have this instrumentation, so we go up to this level lah, analyze 13 variable. So from here, by having a multi-variable, banyak variable, banyak parameter, kita boleh lihat, we can find or we can study what are the relationship between the variables, between the amino acid in the bovine gelatin itself. Okay, so how about other eight here, sebab kita tajuk kita ialah multivariate, kita pun ada bivariate, we also have univariate. So apa beza dia? So this is just an introduction lah. Okay. So how about univariate? Univariate is when you have one variable for one sample. So for example, you tengok sini, we have sample 1, sample 2, sample 3. Sample 1 is we have bovine gelatin B. Sample 2 is fish gelatin F. And then sample 3 is porcine gelatin, which is, we know it as porcine P lah. Yeah. So within this gelatin, kita hanya analyze, we only analyze hydroxyproline, HYP. Yeah. So HYP is only one variable. So from this variable, we can display the result using this table of frequency. Berapa banyak porcine, berapa banyak bovine, porcine, berapa banyak bovine, and berapa banyak fish. Okay, according to concentration lah. Yeah. So this one we call it frequency distribution table. We can also display the result of univariate data using a pie chart. Yeah. So perhaps this blue color is fish. Yeah. Yang this one perhaps bovine, and then this one is porcine, for example. Yeah. We also can convert the pie chart into bar chart, and then according to concentration. So this is three ways of common way to display the result of univariate if you have one variable. Yeah? So with this one variable, we also can conduct a test using t-test, ANOVA, man-Whitney test, Wilkinson sign rank test. Yeah. So this is the common one that we have learned if we using univariate. But for this workshop, we are not going to discuss this one. We just share what we are focusing is the multivariate. Yeah. So before we move to multivariate, kita tengok pula how about bivariate. Bivariate is you have two variables for one sample. Okay. So by having a bivariate data, we can conduct a Z test or kita panggil Z test, to measure difference of mean between two groups using one variable. Okay. We also can conduct chi-square test to check the presence of relationship between two variables. Contoh paling kecil, sorry yang ni. This one is hydroxyproline. This one is histidine. So there are two variables. Yeah. But these two variable we analyze for porcine only. So we want to check the relationship between hydroxyproline dengan histidine. Yeah. Kalau kecil sangat nanti cakap but for this one we want to check, so we carry out the chi-square test lah. So you can see here the interpretation for this comparison between for chi-square test. Kita akan, when we talk about statistic, there is a hash null, hypothesis null. The hydroxyproline and histidine are independent, which is they are not correlated. This is the common chi-square test, null hypothesis for chi-square test. The alternative hypothesis is there is a link between hydroxyproline and histidine, meaning that they propose hydroxyproline and histidine to be having a correlation. So to know whether they have a correlation or not, we will compute the p-value. So the p-value carried out by the XLStat is here. Dia akan bagi tahu this value lah, 0.364. Okay. The good thing and the one that we set up is at alpha 0.05, meaning that 5% wrong, 95% correct, having a relationship. Okay, so at 95% correlation, 95% confidence level, we can kita panggil apa deduce that as a computed p-value 0.2364 is greater than significant level alpha 0.05. Dia lebih besar, 0.2364 lebih besar daripada 0.05. One cannot reject the null hypothesis. What is our null hypothesis? Hydroxyproline and histidine are independent, which indicate memang betul hydroxyproline and histidine doesn't have any correlation. So you boleh baca kat sini. The good thing about XLStat, if they give you the value of p-value, they also give you the 0.05 value. They will interpret the data, the result based on this chi-square test. They will provide this interpretation. So lagi mudah for you untuk interpretation lah. Yeah. I'm not so sure about other software. I think other software also has the capabilities, but since I'm quite familiar with this one, so that's why I share with you the good thing about this XLStat lah. Okay. But if you already have other software, you just and then you are very familiar with the software, maintain with that. Make sure that the aim of having this workshop is you able to interpret the result. Okay, so again, dia kata kat sini, as the computed p-value, which is 0.2364, is greater than the 0.05, one cannot reject the null hypothesis. And the null hypothesis state that hydroxyproline and histidine are independent, which they are not having any correlation. So dekat sini, we will say that dalam porcine ni, hydroxyproline dengan histidine, amino acid are not having any correlation. But this one only for porcine. Kalau we have bovine, kita ada fish, the relationship might be different, might be present or might be the same lah. So this is how we analyze bivariate data. Okay. Another approach of analyzing bivariate data to check the correlation by carry out a scatter plot, or we call it regression analysis. So you can see here the hydroxyproline and histidine we can plot. Hydroxyproline dekat sini, and then this one histidine. So you can plot up the regression analysis, so you can see the R square is 0.136. So they relate lah, very low correlation. That's why they say hydroxyproline and histidine are not having any correlation. Okay, so usually if we have bivariate data, we would like to check the correlation. We will go to the chi-square test and even do scatter plot lah. Okay, so yang ni common if we learn in our undergrad, yang ni common lah. For those chemists, when we carry out a calibration curve, that is also a bivariate data lah. Okay, okay, so now again, why multivariate? Kenapa kita buat multivariate? The aim of having multivariate is to identify the sample grouping, to identify the significant variables contributing to the sample grouping, and then we can also predict sample grouping using a testing data set. And however, for food sample, data are becoming increasing multivariate in nature, and response measures comprise several univariate types, including sensory and instrumental discrimination. Okay, so as I told you previously, untuk environmental studies, data there is too comprehensive, too much, so they are coming together with multivariate all the way. We don't have to wait for more data. However, in food studies, we need to collect the data one by one. But as time goes by, with advancements of technology, the food studies, food samples data are now becoming more multivariate. So that's why I'm proposing this title, multivariate data analysis, so that we can understand the relationship between the variables in the food that we are going to analyze now. Okay, so when we have more than 3 variables for one sample, we may start using multivariate data analysis. Kalau one sample, one variable, we can go for univariate, 2 variable bivariate. So when you have 3 and more, I rasa 3 and more lah, bukan more than 3. 3 and more, we can start using the multivariate to have a correlation. So you can see that this example of again the bovine gelatin, we have 13 variables. Okay, some participant will be asking, kenapa hydroxyproline tu warna hitam? Okay, I forgot to change into green, into yellow. So it's no wrong why the hydroxyproline is labeled as black. Actually, it's similar labeling, but I forgot to change the color. Okay. So just stick to the principle. We have 13 variables. Since this 13 variable is more than 2 or 3 and above, so we may conduct a multivariate data analysis. Okay. This is the one that I'm telling you. Okay, even though we most of multivariate data analysis, we are focusing on principal component analysis. We go to cluster analysis. We can bring discriminant and also multiple linear regression for these 2 days workshop. But before we start, this is the lacking of multivariate data analysis in food studies that I've encountered, and when I've been conducting any or evaluating any reviewing any paper. Okay, dia kekurangan of some prerequisite requirement. Before we conduct multivariate data analysis, you have to fulfill this requirement. First, you have to evaluate the missing data. Is there any missing data? The second one, you need to identify and remove outliers. The third one, you need to collect adequate data set for multivariate data analysis. You have to check whether the data analysis, the data that you have are adequate for multivariate data analysis. And then you may also conduct a assumption testing for multivariate data analysis. which is this is not really critical on this one, but all these 1, 2, 3 are the critical one. Yeah. So most of the time, when we read any papers related to food studies, they just jump their data into principal component analysis without telling us have they conducted these 3 prerequisite step. Ya, so ini kekurangan-kekurangan pada satu data yang menyebabkan sometimes the result maybe become error lah. We have erroneous data. So please be have some knowledge about this one, where we will share within this by today lah. Okay, so this is the prerequisite of multivariate data analysis. Okay, so kita mulakan evaluating of missing data. Kita tak masuk lagi to principal component analysis. We go to evaluate missing data first. Okay, missing data occurs due to undetected variable or detected variable that is below the limit of detection. This issue occurs in method validation and verification works. Okay, kenapa? Sometimes when we analyze of the sample, contohnya we analyze with GCMS, UHPLC, we make a calibration curve, or even if we have a calibration curve based on UVVs. Okay, there is a peak, but sometimes the peak level is quite similar with the height or the area of this kita panggil noise. So are we going to accept that value as a value or a noise? Yang ni lah punca dia. Sometimes people just accept it as it is. Those noise can become the data. Yang ni akan giving a wrong interpretation. So for those who are dealing with HPLC, GCMS, or you are consultant for any researchers, for example, ataupun you are selling some products, instrumentation product, sometimes the client will be asking you, is it correct of this analysis? So you have to check with this one. Make sure the data that they have, the area peak of the sample is not actually the area peak of the noise. So any data that below limit of detection, limit of detection ni kita akan buat dalam method validation and verification. So what we did, kita akan analyze we will accept the peak which is having signal to noise ratio more than 3 lah. If the peak of the sample, contohlah sample you tinggi ni, this is noise. So make sure the height of this boleh hilang. Okay, peak area and the noise area is signal to noise ratio is 3. Okay, so based on this signal to noise ratio 3, we will identify the limit of detection. They will identify the concentration of the peak according to this one. So this is an example of the lowest concentration for each peak. Contoh yang ni, amino acid hydroxyproline, the LOD is 9.85, meaning that any peak that below than 9.85 may possibly or the noise itself. So mana-mana data which is low than LOD might be a potential noise. Actually, it's not a signal. Okay, so in this case, if we want to get to bring this data as for multivariate data analysis, there is a rules. So common practice is by converting the undetected value to 0 value, and ataupun the value less than LOD to 0.5 LOD or 0.75 LOD. Okay, so any data that below of this one, for example, hydroxyproline 9.85, you have to times that 0.85 to 0.5 or 0.75 lah. This is the common practice. However, after we read all this manuscript related to how dealing with LOD data, they recommend that we time the LOD value to 0.65. So this is the recommended version. Previously, there are some researchers suggest 0.5 or 0.75. But from one paper. They try to, you can see in the at the reference, I have attached the paper. So 0.65 times to LOD will be used for multivariate data analysis. So any data that you have which is less than LOD, so you have to times the LOD value to 0.65, and that data will be input into our Excel. So this is an example lah. Okay. Other option to evaluate and treating missing data is by removing the observation. Kita boleh remove the sample itself. We also can estimate missing data by computing the mean. Some statistical software provide algorithm to ignore the missing data as well. So this is an example. Kalau tuan-tuan lihat dalam XLStat, okay, you can choose this one, whether to select do not missing data, accept missing data, remove the observation, pairwise deletion, and even estimate missing data using mean. Okay, but my recommendation, if you choose one type of treatment, all your variable shall follow the same. Sebab when we dealing with multivariate data analysis, it should be uniform lah. All your data treatment should be the same kalau you choose any way of treating the missing data. Tak salah sebenarnya, boleh pilih mana-mana. Okay, ada siapa nak tanya?
Okay, first question from Suryati. Hi doctor, how do we know the data is adequate or not for multivariate?
Okay. For Suryati, later on we will learn about Kaiser-Meyer-Olkin data. So dalam tu kita akan we will identify whether your data is enough or not. Nanti kita akan sampai situ. Ni dah advance ni. Soalan ni dah advance. Okay, nanti kita akan share dalam slide-slide seterusnya. Okay.
Okay, another question by May. In this slide, your meaning is that whatever data is below LOD is taken as 0. If the data is below LOQ, which is quantification value, we should take is as 0 to, right? LOQ is normally taken as per n 10.
Yes, as per n 10. Okay, that depends on your method. Do you want to use LOD or do you want to use LOQ? If we are choosing method, limit of detection quantification, that one for method. This one LOD if we are focusing on the instrument itself. So you boleh pilih mana-mana. So in this case, if we are going to use the LOQ, you have 2 times 0.65 LOQ lah. But make sure all of your variable shall be treated the same. Kalau you nak choose LOQ, okay. Kalau you nak choose LOD pun okay, no problem. Because multivariate, you need to have a uniform way of treating sample data. Okay, ada soalan lain? I hope that will be answering your question.
So far no, doctor.
Okay, if you have any problem, again, jangan segan. We will still accept any question after the workshop end. Tak kisahlah bila-bila pun. We have a few participants coming back with their data, which is they know themselves about how they analyze the data, so they understand their data better lah. So generally, InHalab will assist on the understanding and the interpretation. Okay. So next step of treating your data, prerequisite of multivariate is identifying and removing outliers. So outliers are defined as a variable value that exhibit an extreme value from the majority values. Mana-mana value yang terkeluar daripada nilai-nilai average lah, bukan nilai-nilai kemanusiaan. The nilai-nilai average. If no sample grouping has been identified, kalau you tak jumpa pun sample grouping, you can perform a whisker plot, Grubbs or Dixon test at alpha 0.05 at significant level 0.01. 0.01 or 0.05. It depends on your statistical analysis. If you choose 0.01, it is 99% confidence level. This ones really apply for halal testing. Kita nak 99% correct that particular sample is halal or non-halal. But for other food studies yang related to kita panggil our contamination, we can use up to 95% confidence level. Yeah. Environmental study, they still stick to 95% confidence level lah. But for halal, now people are choosing to have 99% because halal issues is very sensitive. So that's why they want to make sure if it is halal, it is 99% correct. But they still allow 1% in error lah. Yeah. The higher value of alpha, the lower value of alpha is recommended actually, or the higher value of confidence level is recommended. Okay. However, the decision of outlier removal is case by case basis. Maksud dia, tak semestinya you need to remove your outliers. Sometimes you can let it be. Boleh. Tapi there is always a reason. You kena stick to the reason that you choose lah. For example, for halal testing, especially in the same gelatin data, we have database for fish gelatin. Kita analyze fish gelatin, we analyze bovine gelatin and porcine gelatin. So we try to group this gelatin according to their source lah. So this one fish, bovine and porcine. So from here, since we analyze fish gelatin dalam ni, I analyze up to 40 times. Same gelatin sample kita analyze using UHPLC 40 times. Bovine pun 40 times, porcine pun 40 times. So we make a grouping lah. So from here we try to make a box and whisker plot. Any data that falls outside of the whiskers that will consider an outlier. Okay, so in this case, since I analyzed the same data up to 40 times, so any outliers that I found is considered an outlier and I need to remove them. There is some possibility of instrumentation problem or something like that. Okay, this is what I've been told. This is why we call it case by case basis. Yeah, some samples you don't have many analysis, many repetition, but you may find outliers, but that doesn't necessarily mean you need to remove that outlier. Sometimes that outlier indicates something to your data itself, but you need to find the reason why lah. So in this case, macam I punya analysis ni, I analyze and I want to create a database, fish gelatin database, bovine gelatin database, porcine gelatin database. So for each database, according to source, since I run few times, up to 40 times, so when I found any data outside of the whiskers, I will consider that outlier and it should be removed. So this is case one, case by case basis why I treat the data, the outlier as it is lah. Okay. Another case yang I show you, you measure compounds concentration, not for database. This is for not database. For example, you repeat the analysis lower than 3 and lower. And then because of this, you can find a lots of outlier here. Sometimes this outlier will indicate good thing about your data lah. Okay, so you may still remove the outlier if high repetition number is available, but in this case, it is not recommended. Kalau you remove, data you akan reduce lah sebab repetition you low. Okay, this is an example where there is a study we conduct with some researchers about sausage. About sausage. This study about replacing a food fat in the food using a plant-based fat. And then during this replacement, we conduct a formulation lah. Kita buat a few formulation, but you know it's a formulation, so you cannot run too many repetition. So during this formulation, when we plot the box plot, we can get a lot of outliers here, but that will indicate some characteristic which is very specific to that particular formulation. So this is what our research is looking for. Kita nak cari some characteristic yang very specific to that formulation. So that's why we do remove this outlier. So I hope that you can understand why kita remove outlier and why we let it be. Kita tak remove. I go back to this one. This one, we want to make a database, and then we make a high repetition analysis. So from here, when we found any outliers, we remove it. Sebab kita nak buat database. Okay. This case, we have low number of analysis, but the aim of the research, if we want to find a specific characteristic for that formulation, so that's why we didn't remove it, any outlier there. Sometimes this outlier indicates something special for that formulation lah. So dekat sini akan membantu untuk researchers nak pilih formulation mana yang the best. Okay, so I hope this will assist anybody on how you can tailor-made your research. So this is an example of treating outliers. Now coming to, siapa yang tanya tadi? Ili Siapa yang tanya tadi pasal data cukup ke tak? Suryati, sorry. Oh, tadi ada nama Ili tadi. Minta maaf. Sebut panggil suka hati sebut nama orang kan. Okay, now kita come to the next prerequisite for multivariate. Collecting adequate data set. Kita tengah nak identify sama ada data yang kita kumpul untuk multivariate data analysis cukup atau tidak. Okay, so generally we need to carry out repetition lah. Commonly people will collect 30 data to establish the data set. However, this data set yang kita belajar zaman-zaman degree dulu, kan N sama dengan 30. Kalau N lower than 30 kita panggil sample, and more than 30 we call it population, something like that lah. Okay, that is for univariate. But for multivariate, there is a test we call it Kaiser-Meyer-Olkin test. At significant level, ni itu pula lah. Again, you nak pakai 0.01 ke 0.05 or you want to use 0.10, it's up to you. Okay, but this one significant level is up to the research aim itself. Macam I cakap tadi, for halal, now people go to 0.01. For formulation and for identifying contaminant, we go to 0.05. Environmental study, they still stick into 0.05. Okay, so the test that we are going to use to check whether our samples data is enough or not by using Kaiser-Meyer-Olkin test. Okay, so there is a range to check whether your KMO is enough or not. So you can see the value is between 0 to 1. So any KMO value less than 0.5, we call it inadequate, data you tak cukup. 0.5 to 0.7 is medicure. 0.7 until 0.8 it is good. 0.8 until 0.9 is very good, and KMO is more than 0.9 is called excellent lah. Maksudnya data you sangat bagus. Okay. Oh, terlebih telah masuk awal pula. Okay, so however, after reading lots of papers, I find out any KMO value more than 0.5 is deemed as adequate for multivariate data analysis. Yang ni, unfortunately, I didn't found this information from food studies. Again, this is from the environmental studies. This is what I saw. Kita panggil apa the multivariate data analysis between environmental study dengan food studies tu dia macam sangat jauh. Food study baru nak berangkat, environmental study dia dah ke depan. So this value of KMO more than 0.5 is deemed as adequate lah, cukup untuk multivariate data analysis. So we can use this value. However, achieving KMO value more than 0.9, which is this one, is really bagus lah. It's very good kalau you boleh achieve KMO value more than 0.9. Okay, so again, soalan dia, kalau tak sampai 0.5, apa nak buat? Pergilah repeat data you, analysis you. You can add more variables or you can make more repetition. From there, you can get the results. So for example, this one, Kaiser-Meyer-Olkin, we analyze energy, protein, carbohydrate, fat, and saturated fat. So they compute individual KMO, and then they will average the KMO. Since the data set is multivariate, sebab dia banyak variable, so they make an average KMO. So you can see here, KMO value dah 0.2087. Cukup tak ni kalau ikutkan? Tak cukup kan? So what we did, pergilah analyze lagi data, tambah repetition or tambah samples lah. Yeah. So this is the way of how, one way of how to check whether your data is enough or not. Yeah. But again, if you read any papers, even environmental study dia tak sebut juga KMO ni. Some papers are really transparent. They will tell you one by one whether your KMO value for their KMO value is adequate or not adequate lah. Okay. Ada soalan tak sampai sini?
Okay, ada. Kepada
Silakan.
Suriati, how do find the cashier Mayer alkene is it is using SPSS?
Sorry, Suryati. So far, I don't have experience with SPSS. This KMO value, if we are using XLStat, it is embedded together with the PCA. So nanti kita akan tengok, saya akan tunjukkan lah. Yeah. So since if you have the XLStat already installed to your PC, if you want to conduct the KMO, you just use the XLStat for the KMO only. Yeah. For SPSS, I think there is some way of to create this KMO value. Unfortunately, I memang tak mahir on this SPSS lah ya. So this one I have to say, kalau tak tahu cakap tak tahu. So same goes with me. Saya memang tak pernah pakai SPSS for multivariate data analysis. So I don't know where to get this KMO value lah. Yeah. But for SSStat, there is KMO value. So you can try to use SSStat to keluarkan KMO value, and then you can proceed with the SPSS software for the rest of tests that you are preferring. Yeah. Okay, so saya harap menjawab. Saya minta maaf sangat, SPSS saya memang tak mahir. Yeah.
Sorry, Doctor.
Yeah.
Maybe is it using SLStat? So SLStat got KMO.
Yeah, SLStat got KMO. But if you are talking about SPSS, I don't know where to create the KMO value or which to click in the SPSS. In SLStat, yes, there is a way of doing it. Kita boleh klik PCA, dalam PCA tu we can get the KMO value lah. We will share you later dalam hands-on nanti. Okay? Ada soalan lain?
So far no.
Okay.
Got another one.
Okay.
Hi doctor, I have 4 variable but I only duplicate the analysis. Is it enough?
Actually, it can be enough. There is some case which is I assist researcher from Kementerian Kesihatan Malaysia. It's enough even with 2 duplication, but we need to check the KMO value. The one that we assisted is Sister Ganti sebelum ni. She work with the KKM for kita panggil apa ya? Seaweed. Yeah. Dia ada 2 duplication je, tapi when we carry out the KMO, the value is more than 0.5. So still acceptable, provided that you need to have a replication. Yeah. Tapi after KMO test, kalau tak dapat juga dia 0.5 value, so meaning that you have to add more repetition lah. Yeah. Okay, ada soalan lain?
So far no, doctor.
Okay, thank you. So I proceed. Okay, the last requirement is performing assumption testing for multivariate. Okay, this assumption involve normalization, homoscedasticity and linearity of the data set. Okay, nanti kita akan tengok sikit-sikit. Yeah. The good thing is to treat all this normalization, homoscedasticity, linearity, kita hanya pakai satu treatment saja. Dia akan treat all those prerequisite ini. Yeah. So to check dataset normality, the dataset shall be subjected to normality test. Kita boleh pakai Shapiro-Wilk test, and if you go to XLStat, there are another 3 tests to check the normality of the data lah. Yeah. So the non-normal variable values shall be transformed to ensure normal distribution. So you can see here transformation. Yeah. So when we try to get a normal data, we can transform the data. Fortunately, by transforming your data as well will be, this transformed data will treat the homoscedasticity issues as well. Okay, so apa pula homoscedasticity ni? Homoscedasticity refers to the assumption that dependent variable exhibit equal levels of variance across the range of predictor variables. Maksud dia apa? Homoscedasticity bermaksud the distribution of data, yes, from the lower value of your Excel, your x-axis, meaning that your dependent variable and your independent variable are uniform. Dia punya taburan tu uniform. Makin tinggi your x-axis dan makin tinggi your y-axis, dia punya distribution of the data is uniform. You nampak kan? Dia straight saja. This one. So this one we call it homoscedasticity. We are looking for this one lah, for multivariate. Ini kita nak carilah. This is another example which is heteroscedasticity. Dia tak well distributed across the increment of the data set. X-axis ataupun y-axis lah, dependent and independent variable lah. So we want this homoscedasticity data. Okay, so untuk treat homoscedasticity data ni, we need to transform the data set. So again, when you conduct transformation, normalization you boleh achieve, homoscedasticity pun you can achieve. So by transforming your data. Okay. Another one requirement assumption is linearity. So this linearity means you want to have a good linearity between independent and dependent variables. If you see here, the linearity is very bad here, so that's why we can calculate r square is equal to 0. This one r square equal to 1. Makin tinggi you punya x-axis, makin tinggi value y lah. Okay, so linearity, if it is in this form, you can treat the linearity using again transformation. Boleh pakai transformation. So in this case, kita pusing balik kat previous slide. To treat normalization, homoscedasticity and linearity, we can treat all of these requirements using transformation data. Okay, so macam mana nak transform? There are very much so many type ways of transforming your data. You boleh pakai standardized n-1, standardized n. Apa beza n-1 and n? Okay, standardized if your sample is, you can assume there is a sample, the data set. Standardized if your data is very high volume, so that's we consider it's equal to population, that's why we use n. Center, standard deviation n-1, standard deviation n. Again, the similar principle lah. Whether you want to identify your data as a sample or population. Rescaling from 0 to 1. You also can use rescaling from 0 to 100. You can use also Pareto scaling and even log transformation. Okay, for those dealing with microbes, for example, like myself, I dealing with microbial study. So log transformation really assists us on to get a transform data and normal data. Okay. However, for linearity, this prerequisite is case by case basis. The data set transformation correct linearity issues as well. Okay, this one we have already talked. Okay. Okay, dalam banyak-banyak isu ni kita cakap by having a data transformation, they will treat all these three issues lah, linearity, homoscedasticity and normality of your data. Itu memang requirement on multivariate. However, after conducting all this transformation, sometimes the data really don't get 100% normality, don't get 100% linearity and don't get 100% homoscedasticity. So that indicate by transforming your data, we are not looking for 100% treated data. We want to bring the data set closer to normality, closer to linearity and closer to homoscedasticity. Most of the time, banyak juga data that we found after conducting the transformation, the normality is still the same, linearity is still the same and homoscedasticity is still the same. However, some data will get the normality, linearity and homoscedasticity. Some data, they have a nearer to normality, linearity and homoscedasticity. So again, mungkin we have, kalau I'm a writer of any book, I would not say to get 100% normality. We want to bring them closer to normality. That one is the best description lah. Untuk data environment, those that are being dealing sangat susah nak dapat 100% normality for all the variables lah. Some yes, some no. Some even move slightly to normality. Dia takkan achieve normality lah. So beware on that. Sometimes when you send your paper to any publisher, the reviewer will question that one. So you have to explain this way lah. Dia takkan achieve normality, especially if we have less repetition. This normality, 100% linearity, homoscedasticity, we can achieve kalau our data is too much. So by now, people are moving to big data. They collect macam worldwide data macam Google, Microsoft, they collect all of this data. That data actually can go to that 100% normality, linearity and homoscedasticity because of huge data punya section. Compared to our study, generally we have limited sample.
Okay, Doctor. Got a question?
Yes, silakan.
Doctor, from Izzat. Sister Izzat, Doctor, what is the difference between using Anderson-Darling rejoiner for normality?
Oh, okay. Macam ni. Like the way that I show here, kita ada bagi, I ada guna ni kan, Shapiro-Wilk test ni kan. This one is based on common normality test that we can use. Beside of the Shapiro-Wilk test, dia ada banyak lagi normality test that we can use. Termasuklah those that you mentioned. But as I told you, since multivariate data analysis, this multivariate data analysis should be uniform. When you use Shapiro-Wilk test, you have to ensure all your data sets using the similar normality test, meaning that they're using the similar algorithm lah for calculation. Tak ada mana betul, tak ada mana salah, but sometimes people choose certain normality test for their specific kita panggil apa, sample matrix based on their previous study lah. So in this case, Shapiro-Wilk test is one of it lah. So the one that you have, that you propose, also not wrong to use it. Dia tak ada salah, cuma tak ada salah, tak ada betul. But you have to make sure the data, the normality test that you use should be similar, should be uniform, guna yang sama. The difference is definitely having different algorithm lah. Okay, boleh menjawab soalan tu? Ada soalan lain?
So far no.
Okay, so sampai situ, up to that level we reach to this kita dah lebih pukul 10 Okay, kita dah lebih we have reached to this slide which is data example for prerequisite of multivariate data analysis. So kita nak try buat kita try buat sekejap, lepas tu baru kita rehat. Boleh? Okay, saya kecilkan sikit sebab senang nak tengok. Okay, so we will evaluate and treat missing data, identify, removal and remove outliers, and then we can try to collect adequate multivariate data analysis lah. So apa yang kita akan pergi, okay, yang ni nampak okay. So untuk this hands-on, we will open a file, we call it large scale of multivariate data analysis. Nanti ayat akan tunjuk. So this data in this our drive that we share, the data that I give to you is the data that provide detailed information on packaging atmosphere, total mesophilic aerobic flora, lactic acid bacteria and process variable of 70 samples of poultry and beef sausage. Maksud dia buat formulation of sausage using poultry and beef, and then they measure this variable lah, atmosphere, aerobic flora, lactic acid. Together with that, they want to study, the aim of this data, the study is aim to estimate the impact of packaging atmosphere in refrigerated storage period lah. So this study aim to associate this process variable. Ada juga together with this data is other variables such as gas content, volatile organic compound and sensorial properties lah. So kita buat sensory study. Sekejap. Okay, so this is the flow. Macam mana nak tekan. Okay, so kita akan evaluate and treat missing data. Go to the folder. Pergi dekat folder. Oh, saya kena share folder tu Sekejap ya. Saya tak berani nak share screen sebab nanti saya kena kick out macam last time. So, susah kena buang ni daripada kehidupan. Okay, so saya akan tunjuk dekat you semua. Okay, ni sorry. Kita akan share this one. Nampak tak folder ni? Ini. Okay. So, everyone, okay, tak apa. Kalau terlepas, kita ada recording Okay, sekarang ni, open this folder, number 6, data for multivariate data analysis in food studies. Okay, go to workshop data. Okay, you can see there are 2 folders kat situ. The first one is Excel workshop, workbook. The second one is Excel macro enable workbook. Okay, these 2 folders having the similar file. Tak ada issue pun. But why I copy the similar data? I copy the similar data with different format. If you can open your Excel can open this Excel workbook, you can use it lah. But if you cannot, you can use this Excel macro enable workbook. Boleh pilih mana-mana. Data yang sama sahaja. So let's start to open this one. Number 1, file number 1, 7th draft large scale dataset for multivariate workshop. Okay, so this is the data that you are going to see lah. Okay, so saya tak nak buka yang ni. Saya buka dekat saya punya Excel lah. Sekejap ya. Workshop data macro. Okay, I prefer macro enable lah. So this one I buka I punya Excel dalam PCI sendiri. Okay, similar file. Okay. So you akan nampak lah. Okay, boleh tengok tak dekat bawah ni, kan ada color sheet tu, sample data warna hijau and then sample data remove ND. Okay, so I have colored that one into green color as your reference. So you jangan ubah this data lah. You can try play around with the data and make sure if they create a new sheet nanti yang sheet tu adalah the sheet that we are going to that we are producing in this workshop. Those sheet yang I dah color warna hijau tu jangan usik, let it be as the original data for yourself. Lepas ni kalau you nak play around, make sure you ubah lah pakai sheet yang lain. Okay, ataupun copy sheet lain lah. So yang ni nampak boleh Okay, so here kita nak buat sample treatment. Open file number 1, 7 draft and then conduct transform. Okay, macam ni nak conduct transform. Nampak ya? Okay, boleh. Okay, now go to XLStat dekat atas ni. Okay, go to XLStat. So you will see the software here. Okay, there is icon of XLStat. Click that. Okay, so you akan nampak this thing lah. Okay, so now we want to conduct a transformation. Macam mana? Sekejap ya. Okay, go to preparing. Nampak preparing ni, klik variables transformation. Kita nak transform data kita. We want to transform data, our data. Klik variable transformation And then there will be an appearing of one box, dialog box we call it. Okay, so you can see there is a variable transformation there. Click data. Okay, so you start with the mana ya? Okay, pH reading. Go to pH reading cells, drag up to all cheese cells. Itu nampak Rini nampak? Okay. And tak nampak kecil okay, tak apa, nanti kejap saya ulang okay. And then drag down up to the last row, last row okay. Saya ulang balik. Saya kena besarkan kot. Okay, saya besarkan. So kita ada data sini kan, starting from pH reading ni, okay. Go to XLStat, go to preparing data. We want to go to variable transformation. Yeah. So it will appear a dialog box. So on that data dialog box, click that. Okay. Go to pH reading title, sample title. Drag all those cells to all cheese and then drag down or select and drag down to the lowest or the last row. Okay. Sudah. Okay. Then tuan-tuan boleh lihat dalam this dialog box there is a transformation dekat situ. And then dia ada tulis standardized n-1. Okay. So sekejap. Kita tengok balik PowerPoint dia cakap apa. Okay. Conduct transform. Okay. So yang ni, kalau tuan-tuan lihat, bila kita sebut transformation dari standardized n-1, this is the most common standardization transformation method. Boleh pakai yang ini kalau tuan-tuan tak tahu your particular matrix suitability with which transformation method. Tak tahu mana-mana, try dulu standardized n-1 ni lah. Yeah. Else, boleh juga klik dekat others. Oh, ada problem dekat sini. Sorry. Sekejap ya, saya ulang balik. Saya pergi pH reading. Column 1. Oh, dia punya others ni ada isu ni. Tak apalah. Saya terus dekat sini je. Preparing, transformation, pH reading. Okay, saya go down lah. Okay, so dekat sini bila dah choose, you just click OK. Sorry, go to missing data. Okay, you nampak kat situ kan ada do not accept missing data, remove observation, ignore missing data. You can choose lah mana-mana. Yeah. Then click OK. And then click continue. The selection contain numerical while expected to contain only numerical data. Okay. So you can tengok, you can see here. Dapat tak sampai ke sini? Ini bermaksud apa? What this mean? You can read the information. The selection contains non-numerical data. Maksud dia, within the data that we have some non-numerical data. There is a data which is not in the number form. So that indicate you having problem with the data lah. Yeah. So let's go to cancel, click cancel. You boleh sekarang ni you have to check with your original data. Dekat mana yang non-numerical data tu? I already highlighted there, warna merah kat situ. Underneath of 3-methyl-butyl aldehyde, there is ND. So yang ni, ND ni you patut letak apa? You boleh tukar to 0 lah. Yeah? So we can remove this ND if we check this one. Yeah. Saya buka, I open the next sheet, sample data, remove ND. Yeah. The 3-methyl-butyl aldehyde ni, as this one, actually it should be ND kan? So now we change the ND into 0. This is another way lah. Sebab dia ND, not detected. Which mean kalau we analyze with any instrumentation, perhaps the peak is not there at all. So the people in the lab testing, which is already have ISO 17125, they have this LOD semua, they make it in as ND. So when the data came to you, you have to check the data that you have. Is there any non-numerical data here? Kalau dia non-ND, maksud dia not detected. So you have to replace dengan zero lah. Kalau that they for example dia tulis kat sini LOD macam tu. Maksud dia apa? You ask them what is their LOD times with 0.65. Kena ganti macam tu lah. So dalam kes ni sebab dia tulis ND not detected, which mean no peak at all being detected, so you put 0. Okay. Now with this one, you can try to do the simulating. Go to preparing data, variable transformation, click data, go to the remove ND punya sheet. Okay. Click again to page reading, go to old cheese, title, drag down to the last row, and then make sure you choose standardized n minus 1. And then you can click go to missing data. Okay, missing data ni you can choose do not accept missing data ataupun remove observation. It's up to you lah. So sometimes you can choose do not accept missing data and then click OK. And then click continue. So dapat tak yang dekat sini? So if you can see here, okay, sekejap ya, saya kena besarkan sikit yang ni supaya orang nampak. Okay, so you can see here they create a new sheet. This XLStat create a new sheet. We call it variable transformation. So all this data that you have are the transform data. That's why you can see there is a minus value. Yeah. Okay. Before kita move to another prerequisite, okay, allow me to share, kita share sikit pasal again the variable transformation. Kalau kita buka, we open up the variable transformation again, they will open to the similar dialog box. So you can see the transformation that we choose is standardized n minus 1. As I told you, this is the most common one. If you don't know which transformation method is the best for your matrix, for your sample, you can choose standardized n minus 1. If you click other, cuba click other kat situ. Okay. Kalau you click other, you can see the transformation tab here will activate. Okay, cuba klik kat situ. When you open up this transformation, you will see a lot other ways of transformation method. Kita ada standardized n, center, standardized n minus 1, standard deviation n minus 1, rescaling, 0 to 1, 0 to 100, Pareto scaling, binarized RC, macam-macam ni lah. Okay, so you can choose one by one from here. So yang ni we call it variable transformation. Okay. If you really don't know, for example, in my case, in gelatin, I know that some of method of gelatin is good using Pareto scaling. Lots of paper that use Pareto scaling for food studies. So if you found that the similar study using Pareto for transformation, you just click Pareto scaling and then conduct the transformation. Kalau tak tahu, you can go to standardized n minus 1. Okay, so this is the how we do the variable transformation lah. Okay, then dah 10:30. Okay, sekejap. Kita pergi to identification and removal of outlier. Saya share semula the slide. Takutnya kena campak keluar kalau share screen. Minta maaf ya. Sepatutnya kalau share screen lagi mudah ya. It will be easier. Okay, so I share again the slide. Now we are going to carry out identification and removal of outlier via box and whisker plot. Okay. Again, this one we want to identify outlier. Okay. So go to your Excel micro enable workbook tadi, ada data, pergi ke file number 2, outlier removal. Sekejap ya, saya share balik. So kalau saya share folder, Okay, outlier removal. Go to file, having a name of outlier removal. So yang ni saya boleh tutup lah. Yang tadi dah just nak tunjuk you how to carry out transformation, and then what are the other transformation method yang we can use as an option lah. Okay, outlier removal. Okay, this one pun kena besarkan. Saya buka Excel. Okay, nampak Excel ni? Okay. So again, we are using the similar data lah. Okay. So again, you can see sample data remove ND ni, I terus bawa to this number 2 punya file lah sebab kita tak nak yang the file that having ND value. We don't want that one. We want the data with a proper numerical data lah here. Okay. And then another sheet here, we show that the description result of box plot. Okay, so yang ni keep it as it is. Ini for your reference lah. So we want to do it on our own. This is we will do it later. Sekejap lagi. But this one is the how the result looks like lah. Okay. So again, sample data. Takkan buat. Okay, open file to outlier removal. Okay, choose standardize. Okay, go to so by opening this file, go to XLStat again. Click the XLStat icon. Dia suruh buat apa tadi? Standardize. Kenapa dia nak standardize? Okay. Okay, I punya suggestion, since kita nak buat whiskers plot kan, we can go to this one, descriptive statistics. Sekejap ya, saya tengok balik. Oh, okay, faham. Okay. Standardize is the suggestion. Okay. Okay, so this one, open up your XLStat, go to describing data, then choose descriptive statistics. Saya ulang, we'll repeat, go to XLStat, open up the XLStat icon, go to describing data, choose descriptive statistics. Okay, so from here, okay, you akan nampak this dialog box. Quantitative data. Okay, this quantitative data is all the data starting from this pH reading until to the last variable lah. Okay, so macam ni nak click here, click again the data, go to the, sekejap. Okay, go to pH reading title, drag to the last variable, old cheese, and then drag down to the last row. Okay, dapat? Okay, sampai situ, you go click sample labels. Dia kena ada sample label kat sini. Sample labels. Okay lah, boleh lah, klik dulu. Okay, boleh, ini okay. Okay, and then go to options. Options you have to click kita tak mau. Descriptive statistic tak perlu, charts tak perlu, standardize perlu. You have to click standardize. Sebab in the previous nota kan kita previous hands on kan we carry out standardization and -1 so click standardize. This one confidence level according to your study. Macam if I want to focus on this one is on sausage, I go to 95% confidence level lah. If I'm dealing with halal data, halal testing approach, I will go to 99%. Okay. Oh, dia tak boleh macam tu. Sorry. Descriptive statistic tu you kena buat. Click charts as well. Sorry, descriptive statistic perlu buat, and then charts as well. Okay, and then when you go to output, you akan you will saw a quantitative data side on the left one. On the right one is qualitative data. Yang left ni quantitative data, the right one is qualitative data. Since our data is quantitative, so dia akan activate lah. So you just click all. Okay, salah yang ni, all. And then for charts, go to charts, you click box plot. Quantitative data, click box plot. And then go to options. Go to options. Okay, you boleh klik group plots. Letaklah 20, meaning that in one box plot, how many variable they will display. So the maximum is 20. Meaning that, and then you have to click variables lah. This one for minimum, maximum, outliers ni you have to click. Boleh? Okay, so again, go to general ni, you have to choose the data. Starting from page reading, make sure you click sample labels. Go to options, make sure you click descriptive statistic, charts and standardized. Descriptive statistic ni kalau tak nak buat pun tak apa sebenarnya tau. Tapi tak apalah, kita klik je. For output, you akan tengok there are two sides of data. The left one is quantitative data. Since our data is quantitative, numbered, so it's quantitative lah. And then qualitative data is on the right side. Since we are quantitative one, so it will activate lah. So you click all. Charts, charts one ni, okay. On chart type, make sure you click box plot because we are going to create the box plot. And then you will go to options. On option, click group plots, dimension put 20. Meaning that they will display 20 variables. If you have more than 20, only the first 20 will appear. So you have to carry out a box plot in another run lah, for that particular individual. Sometimes, if you have too much of a variable, you have to separate lah into two. Unfortunately, this is the lacking of the XLStat lah. Okay, and then you click OK, and then it will appear the window or dialog box, and then you can click continue. Okay, so you can see here within this sekejap ya, so ini I kena besarkan this one. So they will give you the statistical information, pH up to your whole cheese, and then you can see the box plot here lah, macam ni. Okay, ada different kan yang ni? Yang ni, it's either you want to this way or another way lah. Cara susunan sahaja. So you can see any outlier will be identified as X outside of the whiskers. So kita pergi yang ni lah, clear skip. Okay, so you can see this is the whiskers, left and right. This is the box. So the red colored is the mean of that particular variable. So this one for all cheese. And then you can have a minimum and maximum value. Outlier will be labeled as round color, round sign. Another one is X sign. So generally, those round point that indicate the outlier, the first outlier which is nearer to the whiskers, the one with this X sign, ada pangkah tu, yang tu outlier which is higher. So this is how we create the box plot, and from here we can identify the outlier. Okay, sampai situ okay Boleh, Nomi okay? Ini okay? Tak dapat? Mana-mana pun boleh. Sepatutnya we can start from pH reading. Actually, it's up to you. You nak pakai berapa variable pun. I just want to show you how to create the box plot. Asalkan dia keluar box plot tu, Alhamdulillah lah. So this is the result post plot. Boleh? Okay. So sampai situ, I will continue to the last one before kita rehat sekejap. So the next slide, the next session is about kita nak identify, we want to identify how we want to ensure the data that we have is enough, which is we want to carry out a Kaiser-Meyer-Olkin test. Okay. So now open file number 3. Open file number 3. Okay. So the file will be named as 3.kmo. KMO stands for Kaiser-Meyer-Olkin lah. Okay. So open up this one. Okay, again so tuan-tuan boleh lihat, tuan-tuan dan perempuan, ramai perempuan kat sini kan? Silap pula. Tuan-tuan dan perempuan boleh lihat, everybody can see the similar sheet. We have sample data, which is we have choose the removing the ND value, and then we already transform. Yes.
Dr. Shirwan,
Yeah.
KMO is not open yet.
Oh yeah, sorry. Thank you. Confident ni. Okay, I'm sorry for my confidence level. 95% confidence level tak 100 kot. Okay, tuan-tuan, ladies and gentlemen, you can see this is a KMO value file. The name is 3.kmo. So you can see a sheet here, sample data, remove ND, and then a variable transformation, which is I have already transformed for all of us. Kita transform dulu the data. This is the data that already transformed. So tak payah pening-pening kepala nak transform. So indicate to carry out the KMO, you need to use the variable transform, the transform variable. We cannot use this original data lah, because we learned previously one of the prerequisite to carry out multivariate data analysis to carry out a variable transformation. So in this KMO file, I have transformed the data, so we will use this data lah. Okay, so again, open up your XLStat. Okay, the good thing about this XLStat is if we want to carry out PCA, Principal Component Analysis, next, later, kejap lagi, we need to fulfill the requirement of KMO kan. Okay, the good thing with XLStat, the KMO test is embedded underneath of the PCA features lah. Okay, so for that case, we need to carry out the PCA itself. Buat je PCA, and then we can get the KMO value. Okay, macam mana nak buat? Sekejap, tengok balik Excel. Dia kata apa? Okay, open file 3KMO, KMO, choose analyzing data, and then click principal component analysis. Click analyzing data. Okay, nampak ya? Click analyzing data, and then there is the second features is principal component analysis, PCA. Okay, so you click that one. Okay, again saya buka balik, go to analyzing data, go to principal component analysis, PCA. Okay, and then there is a dialog box. So in this dialog box there is a part which is named as observations and the variable table, so you have to click that. Click that. Okay, go to the title of PH reading, drag that one until all cheese, and then drag down until to the last row. Okay, boleh so ulang balik, kita pergi balik sini, open up this XLStat, go to the analyzing data, and then choose principal component analysis. Now go to PH reading, drag to all cheese, drag down to the last row. Okay, done with this one. Okay, make sure the data format that we have set is observations / variable table. PCA type is correlation. Okay, kalau you drag down dekat situ, click that one, the arrow. Dia ada tulis kat situ correlation Pearson, covariance and correlation Spearman. Okay, so for those data that already transformed, we will use correlation Pearson. Yeah, and then for data which is not having normal distribution, we will go to Spearman lah. Yeah. Covariant is if we want to find the variance between variables. Yeah. So in this case, since the aim of having PCA later on, we want to find the correlation between the variables. Contohnya dalam that bovine tadi, the amino acid between bovine. So we choose correlation Pearson, and then you have to choose sheet, and then make sure the box variable labels is click. And then for observation labels, kita pun kena klik juga. Click the observation labels. Go to the sample name. Okay, go to the column or the cell having the name sample. Drag down to the last row. Again, make sure PCA type is correlation. You choose sheet, this one. Variable labels should a box shall be click. And then click the observation labels. And then to choose which cell, click that one. So click to samples cells, drag down to the last row or the last sample. Okay, sampai situ okay ya? Saya harap okay. Apa-apa nanti kita boleh repeat. Okay, and then options, go to tab options. Okay, choose standardization n-1. Okay, for the rest of it, just leave it as it is. Okay, supplementary data, ini pun leave it as it is, and then go to data options. Click do not accept missing data. Kenapa? Why we choose this one? Sebab at the first hands-on tadi, kita dah treat missing data, those ND kita dah remove. So this time we will make sure no missing data will be accepted lah. Itu saja for the group, and then go to outputs. Output, okay, click each and every one. Oh, kalau tak nak boleh juga ni. You just click. Sorry, you just click. Tak apalah, klik je lah semua. You just click je semua. Significant level, you choose one. Okay, for output, click semua kat situ. For charts, tak apa, yang ni tak ada apalah. Sebab kita nak tengok KMO saja, so I leave it as it is. Okay, you just make sure the Kayser-Meyer-Olkin box is checked. Okay, so and then you click OK. The selection is kat mana ni? Oh, please select the data under unlock. Okay, selection is empty dekat mana ni? Observation. Oh, this one. Tak apa. Okay. Okay, for this one charts, make sure variables ni you click je correlation chart, vectors, oriented label, colored label. Observation, this one you have to for color by group you unclick lah. Kita tak nak pun yang ni because for this session kita nak check KMO saja. So the rest is okay. And then click okay. Okay. So you will get this features dialog. And then click continue. Okay, so now you will get select access, F1 versus F2. This one just click select and then done. Yang ni kita akan explain in the PCA. For this timing kita nak check KMO saja. Okay. So again, kalau yang tak nampak, again I go for analyzing data, go PCA. Yang mungkin akan confuse ni lah, observation variable ni kena check, click PH until all cheese and then drag down to the last column, last row, and then go to PCA type correlation Pearson, click variable labels. For observation label you have to click the box and then choose the sample title until to the last sample name, last row. For options, make sure you click standardization n-1. Supplementary data is okay. let it be. Data option, you have to choose do not accept missing data. For output, you click each and every one. Significant level ni you boleh letak actually 5% ke 1% ke, it's up to you lah, boleh. Contohlah I nak letak 5% pun boleh. And then you have to check, click charts, dekat charts for variables ni you just click correlation charts, vectors, oriented label, colored label. For observation, make sure that you can click observation charts, label and colored label, but for color by group, you just remove it. Kita tak mau, we don't want this one. By plots, click each and every one. Bootstrap chart ni, you just let it be as it is lah. And then you can click OK. Okay, so you will get this value lah. Okay, you can get the sheet name as PCA. Okay, if you go to the next sheet that I have labeled as green as well, that one is labeled as KMO. Yang ni I rename lah sebab because for this workshop we want to check on KMO saja kan, so that's why I relabel as KMO, not PCA. But the common result will be PCA lah. Since KMO is embedded in the PCA, so you will get the result lah. KMO dalam PCA. So this is the result. You can get the summary, statistics, pH reading, how many observation. Sekejap. Okay, sampailah the whole variable lain, whole cheese. Sekarang we want to go to KMO. Go to KMO, go down until you reach to this file section. We call it as Kaiser-Meyer-Olkin measure of sampling adequacy. So they already indicate there your sampling. Is it adequate or not? So you can see individual KMO being computed for individual pH lah. And then they make an average value. So since multivariate is a combination of all variables, so they computing the average value of the KMO. So you can get here 0.7591. So based on this, macam mana? Cukup atau tak? So in this case, the data that we have for this sample of sausage sample are enough for multivariate data analysis. So by looking at this value, you can proceed to other PCA, you can go to cluster, you can go to discriminant, and you can go to multiple linear regression. Okay, so this is the KMO step. Okay, so sampai situ, up to that part, we have reached to the end section of the prerequisite treatment of data lah. Okay, ada soalan tak sampai situ?
So far at the chat box, no.
Okay.
Anyone?
So if there is no, tak apa, tuan-tuan jangan risau, kita record video ni. Kalau terlepas, you boleh tengok balik lah, nanti kita akan attach this recording as part 1 for today. Hari ni juga kita akan upload lah. So that petang nanti atau malam nanti you can try again. And then tomorrow kalau having problem you can ask lah. Okay, so since we are reaching 11, my request kita rehat dalam 15 minit boleh? Dalam 11.15 nanti kita sambung PCA, kemudian baru kita continue dengan cluster analysis lah. We will end at insyaAllah at 1 PM lah. Okay, we meet again at 11:15. Thank you everyone. Okay, everyone. Assalamualaikum warahmatullahi wabarakatuh. Okay, I think we shall proceed with the next section. Okay.
Dr. Shirwan,
Yeah.
before that, we have one question.
Yes.
If I from Sister Farhana,
Mm-hmm.
if I have three different sources of samples, for example, bovine, porcine, and fish sample, do I need to do the prerequisite analysis individually?
Yes, correct. You have to do it individually, especially on normality and then outlier removal, especially as well if you carry out multiple repetition of samples. Yeah. So that is my recommendation, lah.
Okay, that's all.
Okay. So thank you for the question. Yeah. Again, tadi Sister Farhana.
Yes,
Okay.
Sister Farhana.
So Sister Farhana, I think if you after the workshop, this 2-day workshop, if you really need my assistance on the data, we can have some Google Meet as well, and then we will see what your data look like and what are the possible suggestion for improving or even for analyzing the data lah. Yeah. So please come back to us if you need assistance. Yeah. So now we have reached the end of that prerequisite test requirement for the multiple linear regression. Now we move to the main agenda. We lama dah sampai main agenda ni. Part A, which is principal component analysis in food studies. After the completion of prerequisite, barulah you layak nak buat multiple linear regression. Multivariate data analysis. So the first one is principal component analysis, and sometimes people call it PCA lah. PCA in food studies. Okay. So what is PCA? We will look first at the multivariate data analysis, the type of them. Okay, so this is I took from one of papers lah, and one of the books related to multivariate data analysis. We have lots of multivariate data analysis approach with different requirements. But we are now focusing on the principal component analysis. So in this case, you can see there are two types. Another word about principal component analysis is factor analysis lah. So let's talk about principal component analysis or PCA. So PCA is the most prevalent method in the literature. Ini memang common. You can find lots of PCA tests lah. It provides an ideal route for introduction to multivariate data analysis. Generally, if you are in the middle of identifying or reading the data itself, I just want to see how the data looks like. People will go to this principal component analysis, PCA lah. Previously, PCA is different from factor analysis because of their algorithm. However, now both are interchangeable because as the advancements of technology now, people can create a algorithm which they can imitate the factor analysis result lah. So nowadays people acknowledge PCA and factor analysis are having similar result, even though at the first place they are having different algorithm lah. Walau bagaimanapun, nevertheless, if you are a researcher, my recommendation, go back to your field of study. Sometimes even your supervisors, sometimes if you use PCA to replace FA, factor analysis, people will not accepting. Most of study that using factor analysis are from social science background, meaning that you are dealing with the intention of eating some food or some sensory evaluation. Sometimes people will go to factor analysis, even though, as I told you, especially in the XLStat, the PCA having some algorithm, they took the algorithm to get the result of similar to imitate the factor analysis result. So that's why people can call PCA and FA as similar nowadays lah. But go back to your field of studies to confirm you want to use FA ataupun PCA. But for today workshop, we are talking about PCA. Okay. Okay, what does PCA to what PCA does to your multivariate data analysis. Okay, so again, this is the data that we have been talking all this while, starting this morning. Yeah? We have 13 variables, and then you have one samples type lah, one source bovine. Okay, and then when you carry out a multivariate PCA, yeah, the PCA will create a new variable where we call it as principal component. Yeah? Number of variable that they create is similar number with the variable that you have. Contohnya, for example, we have 13 amino acid. So the principal component analysis will create 13 principal component. Yeah. Okay, so this is original data. So this PCA will create new uncorrelated data loading with reduced dimension and minimal information loss. So from the PCA itself, it will assist us on, since they said here, reduce dimension. Yeah? PCA actually, it will assist us on selecting which variable are the significant ones. Yeah, that's why they call it reduced dimension lah. Yeah, so for example, maksud dia, we have 13 amino acids, but not all these 13 amino acids are referring or are significant to characterize bovine. So because of that, we can use PCA to select out of these 13 variable, which one are the significant ones. So that's why we use the PCA lah. Again, if you only have lower number of variable, you don't have to go PCA, don't have a PCA. If your variable is more than 3 and above, you can go for PCA. Okay, provided that please comply with the pre-requirement of multivariate data analysis, the prerequisite. Okay, so apa yang PCA ni buat to your data lah. Okay, this is another example of that kita panggil bovine tadi, gelatin. So we have bovine, bee, porcine and also fish. This is an example macam mana result of the PCA can be interpreted to interpret it. Okay, simple saja. Okay, the first one is we go to a variable plot. They will produce a plot, we call it variable plot, which is plot untuk variable sahaja, plot untuk parameter sahaja, meaning that plot untuk amino acid sahaja. Okay, so so you can see here methionine, serine, histidine, hydroxyproline, valine. So ini adalah those amino acids lah. So any amino acids that located together or falls together, they are positively correlated. So in this case, these 4 amino acid, methionine, serine, histidine, they are all 4 positively correlated. Any variables that are oppositely located or oppositely direction, having an opposite direction, are negatively correlated. So this one is positive. These 4 against hydroxyproline are negatively correlated. Why? Because different direction. Yang ni ke kanan, this one ke kiri. Hydroxyproline ke sini. Okay, so what are those having positive correlation lagi? Alanine and lysine, dia dekat, falls together. Even alanine and glue, apa nama glue penuh, saya tak ingat lah. Okay, they are located together. Okay, PHE and LEU here are located together, so they are positively correlated. Okay, then any variable that having 90-degree direction, contohnya alanine and lysine against hydroxyproline, sebab dia punya the direction is 90 degree, indicate no correlation at all. Okay, faham Mana-mana variables, mana-mana amino acid that falls together indicate they are positively correlated. Mana-mana variable or any variable that are on opposite direction, they are negatively correlated. And then any variable or any amino acid in this case having a 90-degree direction are having no correlation at all. So this is the PCA results on variable relationship. So dekat sini you boleh cakap apa? Contohlah ya, methionine, serine and histidine. THR ni panggil apa, macam THR radio pula. Okay, so these four variables ni, amino acids, yeah, meaning that kalau methionine tinggi, higher level, serine also tinggi, histidine also tinggi, high concentration. So this is what is the meaning of positive correlation. Dan and if methionine tinggi, hydroxyproline akan rendah because it is negatively correlated. If serine is high, hydroxyproline here will be lower sebab they are negatively correlated. So that's the meaning of variable plot lah. Okay, so by having this PCA also will produce or yield a plot, we call it observation plot. Observation plot meaning that your sample distribution, and sample plotting. Okay, so for example, on this side we have fish gelatin, porcine gelatin and bovine gelatin. So you can see it, they are located together into their individual group. Porcine located together, bovine located together and fish located together. Okay, the question is, kenapa why this porcine and bovine menghampiri together while fish ni on the other side? Kita boleh cakap apa? Sebab bovine and porcine are both mammalian. Fish dia bukan. So that's why the location are different, and those samples that are located together meaning that they have similar characteristic on certain part of the amino acids. Okay, so this is the way of explaining kenapa those samples are located together and why some of them are not. Okay, now we want to characterize which amino acid, which variable characterize the sample itself. So apa yang kita buat? We overlay the variable plot onto the observation plot ataupun vice versa lah. So this plotting, overlay plotting, we call it biplot. Okay, so you can see here, kita ambil je yang this one, kita masuk je dekat, combinekan dekat sini, dapatlah this one biplot lah. That's why we call it biplot. There are two type of plot here, overlay together. One is variable plot, overlay on observation plot. So you can see here, methionine, serine and histidine are characterizing fish together with glycine and arginine. Sebab location of that amino acid falls onto the sample, fish gelatin lah. This one, valine, apa lagi yang ni? PHE, liu, okay, leucine semua, they are characterizing porcine. So you boleh cakap lepas ni, kalau that particular amino acid in one unknown sample having high valine, high leucine, high PHE ni, that will indicate possibility of having porcine source. Okay, again, macam mana pula dengan bovine ni? Okay, for bovine, they have average hydroxyproline. Why? Sebab hydroxyproline is in the middle tau, kalau ikutkan, but it is nearer to bovine lah. Hydroxyproline ni dia between porcine and bovine. That's why, but it's nearer to bovine. So if you have hydroxyproline, high hydroxyproline and low glycine and arginine, itu akan menandakan you have bovine source. Kenapa why I talk about glycine, low arginine? Because glycine is on the opposite of glycine and arginine are opposite of bovine. So yang ni akan rendah lah compared to in bovine. So high hydroxyproline, low glycine and low arginine will characterize the bovine source. So by having this kind of PCA approach, you can characterize the source of the amino acid can characterize the source of your gelatin. Same goes with any samples lah, provided you have the PCA results. Okay, so before sampai situ tak ada soalan lagi? Ada soalan lagi?
Tak ada lagi.
Tak ada Okay. I move to study case halal fish feed. Okay. If you remember, there is one case or lots of case in Malaysia, especially in Perak. There is some case people who breed the fish dalam sangkar in the cage, where these fish are given kita panggil apa ya, a najis lah. Sometimes they feed the fish with porcine sauce. Sometimes they feed with the animal manure, for example. Okay, so this fish which is being fed with the kind of what call that one? This kind of food, this kind of feed, we call it al-jalalah lah. So because of this, there is a researcher from UPM. Okay, they create a study case on halal fish feed lah. So this is what we face in certain area in Malaysia. So this occur in Perak actually, but in Kuantan there is no report at that particular of time. So this is, we call it a jalalah fish lah. So because of that, there are some researchers in UPM. They prepare a formulated fish feed for fish feed by adding some porcine lard, adding lard, and some of the formulation are added with formulated palm oil. Okay, so from the result, they produce this result. They analyze the fish feed using DSC, scanning calorimetry, and then they analyze they analyze with HPLC to get this triacylglycerol TAG, and then you can have this TAG list. From here, they will get the principal component for each of that variables, and from here they can identify which TAG characterizing the fish feed containing pork and fish feed containing mixture of pork and then containing palm oil only. Okay, so you can see this POO, PPO, and PPL are characterizing any fish feed containing pork only. This TAG, triacylglycerol, they are characterizing the they are characterizing lard containing fish feed. POO, PPO, and PPL. Again, I'm sorry, this one. They are characterizing the fish feed containing palm oil only. This one palm oil. This one lard saja. You can see here 100% lard, 0 palm oil. 0 lard, 100% palm oil. So in the middle, CT2 and OOOLLN are characterizing the mixture of lard and palm oil fish feed. So in this case, if we analyze the fish feed using HPLC to get the TAG, and if you found the high content of CT2, OO, and LLN, so that will indicate a mixture of lard and palm oil are present. Okay, so this is an example. And then you also can identify, okay, among of these TAG, which one are the significant one. Okay, to identify this one, you can go find this factor loading that being created by this XLStat. So any factor loading having 0.750 indicate the strong significant variable, significant TAG. Any moderate variable with moderate factor loading have a value 0.5 until 0.749. Any variable or TAG having weak factor loading, if they have factor loading value less than 0.499. So you can see those bold factor loading are the variable having a strong or a significant one. So you can see OLL, PLL, OOL, POL, and the rest having a significant variable, which means these variable are significant TAG that characterize the fish feed sample. Okay. Again, this one, we talk about positive and correlation, negative correlation, macam yang sebelum ni punya slide. This one, we talk about this one, right? Positive and negative correlation. You also can read or identify the correlation from the table lah. Mana-mana positive correlation indicate they have a positive sign of factor loading, indicate positive correlation. Any variable or any TAG having negative sign indicate negative correlation lah. So dekat sini you can see OLL having value factor loading of 0.8, negative 0.8, PLL having negative 0.9. Since both of them having negative sign indicate they are positively correlated. But my recommendation for this explanation related to positive or negative correlation, better we explain through the diagram. Lagi senang nak lihat lah daripada if compared to using the table lah. This one will be easier to see. You can see again here POO, PPO and PPL having no correlation with CT2. Kenapa? Sebab dia ada 90 degree dia punya kedudukan, especially POO, sebab POO punya direction is really 90 degree hectare. Sini.
So if you want to explain the result, we explain the bold one, the strong.
Yes. No, we can do it any. We can focus on the strong factor loading, or we want to explain each and everything. But sometimes when we want to submit to paper, sometimes examiner will say those insignificant one or weak factor loading, you just let it be because we are not focusing on that. But for knowledge, I think they will be good because you will train yourself to choose which one is strong, moderate or weak. Okay, sampai situ ada soalan tak?
Tak ada lagi so far.
Okay, I hope that everyone can stick with me. Nampak macam pening kan? Ataupun tak. Okay, for those who know about PCA, I think this one will become your refreshment. Just not refresh what is the PCA is all about lah. Okay, so now we go to hands-on of PCA. Okay, so the data that we have, yang ni untuk Azri ni dia memang suka sebab ni data-data McDonald lah. So those who've been joining in Hard Laboratories workshop previously using FTIR, so we have FTIR. We in the workshop previously we attached together or teaching the participant on how to incorporate the PCA in their FTIR. But the data that we use is the McDonald menu. Okay. Since sekarang baru pukul 11.39, dilarang lapar ya sebab kita bercerita tentang McDonald. Okay, so this is the McDonald menu. We are going to use the McDonald menu to carry out PCA lah. Okay, so please take note on the explanation during the hands-on lah. Okay, so about McDonald menu, I would like to explain first. Okay, the data that I'm going to share are the one that we have in the folder. We have nutrient information on the 13 McDonald's menu. Ini nutrient ni dipanggil, tak salah. Okay, these nutrients include energy, protein, carbohydrates, fat and saturated fat. Okay, so we just send this McDonald's data, menu to any lab and then request the lab to carry out the test for this parameter lah, or for these variables. Yeah. So allow me to share the data itself. Saya kena buka dulu. Okay, tuan-tuan dan puan-puan, kena buka. You need to open the file. The file that you need to open is this one. Number 4.pca. So buka yang ni, open up this file. Sekejap, saya share semula. So KMO tadi dah boleh tutup Sama je sebenarnya kalau tuan-tuan lihat di KMO dengan PCA, we are going to use the similar one lah. Okay. Okay. So you can see in this sharing the screen that I share. Okay, so the sheet of that we are going to refer is single McDonald's, variable transformation and PCA only. Yeah, the rest ni memang not what you call that one. I just try on my own. So you boleh delete lah yang ni. Yeah, kalau ada in your file. If not, because we are going to refer to these three sheets only. Okay, single McDonald's, variable transformation, and PCA. Okay, before that, before we carry out the PCA, so the PCA have been done here. Yeah, you may need to go to variable transformation. So your data has been have been transformed first. Yeah, from the single McDonald's in order for us to comply with the prerequisite. Okay. Okay. Macam mana nak buat? Oh, yang ni sepatutnya saya kena delete ni. Rini punya tu keluar tak macam saya punya ni dalam file tu? Ada benda yang sama bukan, what I mean yang contoh-contoh ni. Kalau tak ada okey lah. Okay. So, let us go to the PCA. Okay, macam mana nak buat? Okay, open file for PCA and then conduct transformation. So your data already transformed, tak payah pening kepala. Yeah. So if you want to know about transformation, go back to the previous prerequisite method, macam mana nak buat. So I have already transformed your data. Okay. Use the transform data, choose analyzing data and click principal component analysis. Okay, kita akan buat the similar thing like the KMO lah. Okay, go to XLStat. Yeah. Go to analyzing data and then choose principal component analysis. Okay. Now, using the observation and variable tables here, okay, you will get a table there. A dialog box. Yeah. So observation table, observation/variable tables. Click there. Now, click the title of energy, kilojoule per gram, drag to saturated fat, and then drag down to the last row. Okay. Then, for data format, make sure you click observations/variable tables. Make sure as well for PCA type, click correlation or choose correlation Pearson. Pilih yang tu, kena pilih yang tu. Okay. And then on the sheet, make sure it is selected sheet, SHEET. And for variable labels, make sure it is tick. Yeah. And for observation labels, tick the observation label and then choose McDonald's sample title and then drag down to the last menu, Sunday caramel. Sedap Sunday caramel. Yang bagi alasan nak beli. Okay, sekejap kita pergi balik. Observation labels, go to McDonald's samples title, drag down to Sunday caramel. Boleh? Okay, so saya ulang balik. For observation labels or variable tables, click energy, drag to saturated fat, and then drag down to the last row. Make sure you click PCA type is correlation Pearson. Choose sheet and then ensure the variable labels are ticked. The box is ticked, and then observation labels box also is ticked. And then choose the first McDonald's sample cells, the title, and then drag down to the Sunday caramel. Oh, tak nampak so Sunday caramel last kali. Okay. And then for options, make sure you tick standardization N-1. Okay. For supplementary data, we let it be as it is. And then for data options, click do not accept missing data. Kenapa? Why we click this one? Because at the first place, we thought that we already treat the sample lah. All the missing values, LOD lah, semua those things we have already treated them. Okay, so for now, kita memang we don't accept missing data at all lah. Okay, for output, click all of it. Significant level ni you boleh letak lah dalam 1% ke 0.5 ke satu je lah, ataupun 5% pun boleh. Okay, but we just stick at this. Kita just want to check how the PCA result looks like. Okay, click each and everything in the outputs, and then for charts ni ada yang penting. Okay, variables. For variables tab, you click correlation chart, tick also vectors, tick oriented labels, and also colored labels. Okay. For observation, click observation charts, labels, and colored labels. Itu saja. For biplots, okay, click the biplot, tick the biplot. Options for variable and vectors and labels are tick. Option for observation, labels also tick. Make sure for the type of biplot we choose or you choose correlation biplot. Coefficient shall be automatic lah. Okay, so again for this biplot tab, make sure all these are ticked. Biplots, option for variable, vectors, labels, options for observation labels, and for type of biplot, click correlation biplot. Coefficient shall be remain as automatic, and for bootstrap chart, let it be. Okay, macam tu saja. And then you click OK. Okay, after that you will see a new dialog box. So it will indicate selection name, number of observation and variable table is 13 rows and 5 column. Why is 5 column? Because we have 5 variables lah, or 5 parameters. Why there is a 13 rows? Because we have 13 and menu, McDonald's menu. So observation labels also 13 because observation means samples menu lah. So 13, column is only 1. And then click continue. So then the PCA will display the we call it another dialog box which is having axis F1 and F2. So this is indicate the PC1 and PC2. If we have PC1, we have 5 variable, you can see we can get F1 until F5. 5 variable indicate there is 5 principal component being generated by the PCA. So that's why they are the F5 lah. So sama ada or whether they use the word F or they will use PC, principal component lah. But for PCA, this XLStat, they rename the PC with F value lah, F sign. That's why we have F1 until F5. Sebab ada 5 variables. Same goes with ordinates. Satu tu part CX, satu tu part CY lah. Abscissa and ordinates. You also can see there is F1 until F5. Okay. So generally, the first PC, F1 and F2 will bring the highest number of variable cumulative. Yes. 75.99%. Apa maksud dia? All of these 13 menu that we have and those 5 variable that we have, 75.99% of all the data of this data are being explained by the PCA, meaning that they have a value, something value for our output lah. So now you click select and then click done. Okay, so you will get a result of PCA. The name of that sheet is PC1, PCA1. Kenapa? Sebab we already have PCA lah. So if you reanalyze the same data and then you click analyze again, they will create PCA2. So for this one, I recommend to read PCA sheet. Cuba buka PCA sheet tu. Dapat So in this PCA sheet, you can see there is a small box, colored box. This colored box is the note that I have written for all of you so that you can understand what is the meaning of these things. Okay, so kita tarik satu-satu. Dia akan lama sikit lah sebab kita nak bagi orang faham. That's why we call it workshop lah. So we go to PCA, go to summary statistic. Kat sini saya kena besarkan sikit. Okay, summary statistic here, this is the descriptive statistic. They will show you how many variables that we have analyzed. So kita ada 5 variables or 5 parameters. How many observation ataupun how many menus of the McDonald that we analyze. We have 13 menu, so that's why tulis 13 lah. Number of missing data, there is no, sebab memang tak ada langsung, because we already treated in the prerequisite step. Observation without missing data pun tak ada. Okay, so they will show you the minimum, maximum value, mean and standard deviation. Okay, soalan dia dekat sini. Kenapa the standard deviation already stated here as 1? Kenapa dia 1 standard deviation dia? Kenapa dia 1? Kenapa mean value is 0? Because this is not the original data. This is the data that we have transformed. So which means the data already follow normality test. That's why the standard deviation will become 1, mean will become 0. So dia macam ni. Mungkin at the first place data asal akan macam ni. Dia skewed. But when you conduct normality and then they will move here. So you will get a 0 value and then standard deviation is only 1. So this indicate the data that you have is already normal. Okay. Then we move to the next part. Kita akan cerita sikit pasal yang ni. Okay, correlation matrix. This correlation matrix indicate that positive and negative correlation among the nutrients and has generated guideline lah, meaning that you have energy, protein, carbohydrate, so on and so forth. So all of these variable, we can see the correlation among them. Okay, so you can see any correlation value within the 0.7 until 1, they have strong correlation matrix. CM is correlation matrix lah. So mari kita tengok mana yang strong correlation matrix. You can see fat and energy having a strong correlation matrix because 0.8 value. Maksud dia, you eat more fat, you will get more energy. That's the meaning of correlation lah. And then any 0.3 until 0.7, we call it moderate correlation matrix. Any nutrients less than 0.3, we call it a weak correlation matrix. Betul saya panggil nutrient boleh lah I call variable ke apa ke, but similar thing lah. Okay, the guideline depends on type of study field. Okay, again this guideline I found it from environmental studies. So far there is no guideline from food studies until that currently when I publish a paper related to halal, I bring this correlation to the food studies so people can follow this guideline at the first place lah, as a reference. It's up to anybody actually. So explanation here, you can see energy and fat, energy versus fat having strong and proportional correlation matrix. Okay, proportional ni datang mana pula pening kepala kan. Proportional mean the sign that you have on at the correlation matrix value. So you can see energy and fat having positive correlation, but there is no negative sign there, indicate they have positive correlation. For example, we have protein versus carbohydrate. We have protein, we also have carbohydrate. 0.72 indicate is also strong correlation, but they are negatively proportional sebab ada because they have a negative value, a sign there. So that's why indicate kalau you makanan for those food having high protein, they will have low carbohydrate. Or those menu that having high carbohydrate akan ada low protein. In this McDonald menus lah. This is not indicate that it can be applied in any samples, but according to your data. Any menu that you have that having high protein will also have a low carbohydrate. So this is the explanation. Okay. And then they have a Bartlett sphericity test. This test to identify the presence of correlation between the nutrient. This Bartlett test can be used to check ada atau tak, is there the presence of nutrients or not. We just want to know, is there any correlation? This ballot test doesn't tell us which variable having a correlation lah, but they will tell us ada atau tak. Yeah? So for this ballot test, they have their own interpretation. We can see at the hypothesis null. Okay, we need to read the hypothesis null and hypothesis alternative carefully. Yeah. For hypothesis null, HO, there is no correlation significantly different from zero between the variables. That indicate between nutrient yang you ada, the propose of the hypothesis cakap, they tell us that there is no correlation at all. Padahal dalam correlation matrix ni dah ada, but this one just statistically evidence lah they want to investigate. Hypothesis alternative say at least one of the correlation between the variables is significantly different from zero, meaning which indicate at least one variables or one nutrients having correlation. Sorry, at least two lah, sebab correlation between two variables lah. So now, as they computed p-value, mana p-value ni? Where is the p-value? P-value is here. P-value less than 0.0001 is lower than significant level alpha 0.05. One should reject the null hypothesis. Kita kena reject this one. Indicate memang ada, there is a presence of correlation between the variables. So this is supported by the result from this correlation matrix lah. Memang ada pun correlation dekat situ. Even though this is proportional or not proportional lah. Whether it's inverse or proportional. So this is just a statistical evidence to support this correlation matrix. Okay, now we move to you can see here dia punya explanation lah. The XLStat software assists you on how to read the test result. The test result indicate we shall accept hash alternative, the presence of correlation between nutrients. This is evident from the correlation matrix. We have strong CM for energy versus fat and protein versus carbohydrate. This is the similar explanation. Then kita datang, we go back to the Casimir-Alkin test. Yang ni kalau dos mesti akan tengok ni kan. Ni pandai-pandai lah explain kejap lagi. Okay, so here the KMO having the rank. So the similar rank in the PowerPoint that I show, we paste here so you can see whether it's inadequate or not. Okay, so you can see here KMO value more than 0.5 was acceptable for MDA, multivariate data analysis, but it's case by case basis. But KMO nearer to 1 is the best lah to indicate your data is enough. So the question is now, KMO value that we have is 0.2087. Do you think the data is enough for multivariate data analysis then? No, sebenarnya data ni tak cukup pun for multivariate data analysis sebab KMO is not enough. So in the case of any researcher sending their paper and I'm the reviewer, akan kena tanyalah yang ni. But again, yang ni I need to explain. Most of the case, sometimes reviewer akan allow saja the value of KMO walaupun rendah. Why? In the case of there is no prior research using the similar data set having a KMO value, meaning that you don't have any, kita panggil apa? Guideline. A cut-off value of acceptable KMO, that one will be accepted. But in the case of environmental study, as I told you, there are so many papers, research using KMO, and then they have more than 0.5 being acceptable. So when we conduct environmental study and we found KMO value is less than that, will become a query. Okay. For food study, unfortunately, there is not much paper or study try to check their data enough or not. So in this case, this one on food, 0.2087 is not enough. Apa yang kita perlu buat? We need, in my case, I mungkin kena beli. We go to McDonald's, purchase many of it. Some of it we can give to Rini and also her friend to eat, and some of it we can send to lab for testing of or adding repetition, sampling, and then we can redo the statistical analysis again. Okay, so up to that, we go to the next slide, which is eigenvalue. Okay, kecil-kecilkan sikit. So this principal component analysis. Now we have reached to PCA results. The rest yang atas-atas ni baru nak cerita on descriptive statistic, the simpler requirement lah, before we jump to PCA. That's why you can see here, dia akan masuk ke PCA after you complete your KMO. That's why the arrangement that way. Okay. And that's why I'm preferring XLStat on certain cases lah, compared to other software. Okay, so in this part we reach to eigenvalues. So eigenvalues ni apa sebenarnya? What is eigenvalue? Eigenvalue is a value that characterizes the matrix we are studying. In this case, we are studying on food. McDonald's menu lah. Okay, so we select F. Okay, again, F ni adalah the principal component lah. So since we have 5 nutrients or 5 parameters, so that is why we have 5 principal component. Again, F ni meaning that F is principal component lah. The PCA create a new uncorrelated variables. We call it principal component lah. Okay, so any F or any PC with eigenvalues more than 1 indicate that that PC shall be written in the study. Meaning that that PC is the significant principal component lah. Kita delete sikit kalau tak nampak. Okay. Okay, you have to remember the PCA means to reduce the dimension. We have these 5 variables. Kita ada 5 variable. Among of these 5 variable, which one are the most significant one? So this PCA will tell us which variable is the significant one. So there are 2 PC that are the most significant one lah, which is F1 and F2, where you can see EV or eigenvalue more than 1 indicate there is a strong principal component. So you can see here F1 and F2 having a EV more than 1. So in this case, these principal component are the strongest. So that's why afterward they will plot F1 versus F2. That's why at the first place, ingat tak tadi, there is one time kita kena klik abscissa and F1 and F2 tu. So generally they are only accepting 2 strongest principal component analysis for explanation. Okay. And then for each of the PC, we will get a variability. Okay, so this variability mean how many variables are explained in the principal component analysis. Berapa banyak data, how many data that you have within that 13 menus and 5 nutrients are explained, are really meaningful in our study. So 41%. 41% from PC1, 34% from PC2. So when we combine as a cumulative value, we get 75%. So total 75.99% of all the data that we have are explained in our PCA. Indicate from all 13 menu and 5 nutrients, 75% of them are meaningful, are significant in our study. Tapi kita tak tahu lagi which one. We will look later on the principal component, individual principal component of the variable. Okay. Okay. Another one. Apa lagi? Ni tak ada apalah, samalah. Okay, as time goes by, as increasing principal component, you will see higher number of cumulative value. Kenapa? Why? Because you add up 41.88 plus 34, you will get 75. And then you add another 18%, you will get 94 lah. And then this 94, you will add 5.7, you will get 99 lah. Unfortunately for PCA, they will plot the two most strongest PC. So you will choose the F1 and F2 only. So tak pening-pening, dia dah beritahu which PC you are going to use. Okay. Now we have another explanation is about eigenvectors. Eigenvectors is eigenvalue that we have here, but this one they put in for individual variable with their own direction lah. Yang tu akan pakai simpler word, which is eigenvector is the direction of the individual eigenvalue for the PC. For the variable in its individual PC. But this one just not so important. The important part is this one, factor loading, that you need to explain. Okay, so again, factor loading, we call it FL. So they have the rank. FL more than 0.750 we consider as a strong factor loading. So any variable having strong factor loading, having more than 0.75 factor loading will indicate a strong or significant variable. So in this case, energy have a strong factor loading. Protein, dia dapat moderate because they falls under or between 0.5 to 0.749. Carbohydrate has a weak. Kenapa? Why? Because factor loading for carbohydrate is less than 0.499. Value is negative 0.072722. Okay. Again, kita nampak kan, this is a sign of negative. So bila ada negative, and then you can see carbohydrate having negative with energy and protein. But again, for PCA, if we want to check correlation using this positive negative correlation, we go back to the diagram. Kita tak akan use this table lah, because we want to make a clear explanation. Use a diagram compared to table lah. But we want to check strong, moderate or weak factor loading, we can use the table. Okay, so fat having a very strong factor loading because the value is 0.912. Okay, saturated fat we have it's not moderate, it is weak because 0.3902. So among all these five, carbohydrate having the weakest factor loading in PC1. Tapi you tengok in PC2, carbohydrate is strong because they got 0.9246. Sebab kita akan pakai this two lah. Okay. Now we move to correlation between variables and factors. So correlation between variable and factors, or we call it factor loading, have a similar value lah. Similar value. So you can see here energy, protein having a similar value macam yang atas ni lah. So we don't explain this one because it's similar one. Now kita nak belajar. We want to learn which variable having a correlation. Okay. Okay. So dekat sini or here, what you can see, ini kita besarkan sikit. Okay, so we can see here energy and fat are located nearer to each other. That indicate energy and fat having a positive correlation. At the same time, protein and carbohydrate are opposite to each other. That indicate they are negatively correlated. Unfortunately, protein and energy having 90 degree. Again, carbohydrate and energy almost having carbohydrate and fat almost having 90 degree direction. So, no correlation at all. So, dekat sini kita boleh cakap apa? The higher fat that you eat from the McDonald's, the higher energy you can get. Lepas makan boleh lari lah. So that's mean lah. So, but some of the menu, if it is higher with protein, they are lower in carbohydrate. Sekarang ni, but nanti kita akan tengok. Later we will see which of those menu having those high and lower protein and carbohydrate lah. Okay, so this is the variable plot. Okay, and then we have this contribution of variable. Okay, for PC1, there's the ranking of nutrient contribution based on this fat, which is more than energy because of this percentage contribution dalam this study, dalam in your data. And for principal component 2, carbohydrate contribute the highest to your study. Okay, and then you can accumulate lah. So from here you can give some we call it ranking ranking strong contribution of the variables, starting from fat and then followed by protein, followed by energy, and then followed by protein, and then also saturated fat and carbohydrate. Okay, this one kalau you tengok, it's almost similar with the factor loading lah. Higher factor loading will having higher contribution of variables. Then squared cosine of the variable. This indicate variable with significant contribution to study. Sama sahaja macam yang atas ni. It is correlated. So you can use this table, or you can use squared cosine table to indicate which variable is the strongest. So samalah tengok fat having the 39% contribution, they have the highest squared cosine values 0.83. So this PCA indicate sometimes they produce a lots of data, but sometimes the data having a similar interpretation. Okay. Now we move to factor score. Okay, factor score is the value used to plot observation plot. Tadi kan kita ada 3 plots dalam those amino acid previously in the PowerPoint. So to plot, we have variable plot. This one. This is variable plot. We also have observation plot or sample plot. So this is the plot lah. Sikit. Kena delete. Kita cerita. Okay. So what you can see here, I have make a grouping. Okay, yang ni sebenarnya, those yellow line is the one that I draw or I drew myself lah. For you, for an easy explanation. Selalunya result yang dapat macam ni je. So what I did, I just drew this one for a better explanation. So you can see there are a few groups from this PCA. You tengok pommes frites. Kalau I salah sebut, beritahu because mungkin ada peminat McDonald. Okay, we have apple pie. They are in the similar group. But you can see sundae caramel, sundae chocolate, sundae strawberry are grouping together. Meaning that they have a similar characteristic. And then you can see all those burgers, they are located together as well. Except you kena nampak tiba-tiba ada fillet of fish terkeluar pula. Sebab again, this is fish sauce which is not mammalian sauce of burger. That's another way. Another way of explanation how fillet of fish is being produced. Mungkin di some of the menu is grilled, some of the menu is fried. So that will assist us on explaining lah. So all burgers in a group. So you can see here. Now I take this, or we take this variable plot, and then we overlay to this observation plot to get this result. This one. So ni pun kena delete. Senang nak cerita. Okay. So bila kita overlay, when we overlay, observation that overlay onto variable has the variable characteristic. So any variable that falls onto the menu indicate that characterize that menu itself. So you can see all burgers have high protein. Nampak tak? Sebab protein falls onto the group. All burgers have low carbohydrate. Why? Because carbohydrate is negatively correlated. Dia ke atas pula. Okay. Fillet of fish contain high fat and energy. Kenapa? Perhaps the way the fillet of fish is being cooked. Cheeseburger has high saturated fat. Kenapa? Sebab cheeseburger and saturated fat are really near to each other. This is also related how they are prepared lah, and even the sauce itself. And sometimes kadang-kadang kita tertipu. We thought that the fillet of fish contain fish, but sometimes actually they contain more sauce lain. Ada sauce lah. For example, what else? Pommes frites, apple pie, sundae caramel, and sundae chocolate having a moderate amount of carbohydrate. Kenapa? Carbohydrate in the middle, and then they are between all this dessert. Okay. Now find the evidence why the result show this way. okay, you may need to investigate the ingredient of McDonald's itself. Okay, so macam mana nak explain kenapa ya, why saturated fat near to cheeseburger, why fillet of fish having high energy and fat. In this case, you have to dig back how they prepare this menu. So in this case, if we are preparing the fish feed formulation macam tadi so we need to investigate back macam for explanation. So you can see pommes frites having high potato oil, apple pie having apple with deep fried. Mungkin because of this having deep fried, meaning that you need to add more oil. So that's why they are located together. For example lah, Big Mac having a beef patty, McFeast is beef as well. So Big Mac dekat mana? This one. McFeast also nearer to each other because perhaps they are having a similar source beef. Cheeseburger ni dia tercampak jauh sikit, but nearer to saturated fat. So because perhaps beef patty plus cheese, that's why they have saturated fat sebab ada cheese. Okay. And then quarter pounder with cheese having a beef patty. Okay, dekat sini. But this one you have to investigate lah. Why? So this is an example that how we can explain more why the nutrient is characterizing that particular menu. Okay. Now go to contribution of observation. This is similar explanation to contribution of variable lah. So this one tak perlu explain because they produce the similar results lah. Okay. Again, this one squared cosine of the observation, similar explanation with the squared cosine of the variable. Higher value of squared cosine having indicate higher contribution of that menu to the study. Okay. So this is the result of the PCA. How you can explain. So when you find out the variable falls to that group of samples or the group of menu, you need to explain more. How? You need to dig back how they are prepared, how they are formulated, and is there any other outside or intrinsic or extrinsic factors that contribute to that. So this is why PCA may assist us. Kalaulah dia letak satu group saja, you cannot explain banyak lah. But they have different group now, and then they have different variable that characterize individual group. That will support us. Lagi senang for us to explain. Okay, so sampai situ we have reached to 12:19. Kita buka soalan kalau ada soalan. Kalau tak ada, kita stop sampai 12:30 dulu sebab lepas tu kita sambung untuk cluster. Cluster tak banyak sangat, sikit je. Okay, ada soalan tak?
So far tak ada lagi.
So far tak ada. Okay, if there is no question, boleh simpan. You can keep the question first. Okay, so we stop at now 12:19. We will continue at 12:30 sekejap. 10 minutes je kita rehat. Lepas tu kita sambung, kita habiskan terus the first day of our workshop. Okay, we will meet later. See you again.
Okay, understanding saya okay ke?
Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you everyone for stick to our workshop. Okay, so kita dah sampai to the last session for today. Sebab kita akan habiskan dalam pukul 1 juga. Okay, so let us continue. Sister Alifa okay saya proceed
Okay.
Okay, so now we move to part B, which is the last part for today. Okay, cluster analysis in food studies. Okay, orang akan tanya apa ni cluster analysis ni? Macam-macam lah Dr. Chiruan ni kerja PCE lah, cluster lah. Okay, generally kalau dulu if I start with environmental study, cluster analysis we start with PCA. Even in the PCA we can get the grouping of the source kan macam tadi, grouping of the menu, but to assist the PCA result we can use cluster analysis. So this cluster analysis is a supporting method actually. However, dia pun boleh buat classification method, or we can call it classification method. They can classify the McDonald menu according to specific characteristic lah, a similar characteristic. So this cluster analysis, or we call it CA, they will form a subgroup of similar objects, or dalam case ni McDonald's tadi, similar menu based on assessment of the distance between measurement of similar characteristic or variable, based on similar characteristic. Macam tadi, similar nutrient lah. An exploration method that search with prior definition. Okay. The good thing about this cluster analysis, they allow we to just running clustering, cluster analysis without buat those prerequisite pun. However, macam I cakap lah, I still request the best thing we follow the prerequisite requirement, so that each time we carry out the multivariate data analysis, we have a firm guideline. So data transformation required dalam kes ni, otherwise measures on large scale with higher values than others would tend to dominate lah. Okay, so this is one of the requirement that we suggest. Buatlah data transformation that we have stated in this morning. Okay, and this cluster analysis OCA will produce a diagram, we call it dendrogram. We will look later macam mana dendrogram ni, rupa dia lah how it looks like. So this dendrogram will draw a dotted horizontal line, ada satu line yang mendatar, across the vertical line of the dendrogram and exhibit several grouping via a number of intercept between the dotted horizontal line. Okay, nanti kita akan explain how it looks like. Okay, the cluster analysis produce a profile plot. Okay, beside of dendrogram, we also can get a profile plot. This plot will assist us on telling us which variable are the main variable or the significant variable contribute to the grouping. Okay, so kita nak buat grouping juga, which is similar like the PCA lah, but most of the time PCA will give us a better explanation. So cluster can become a supporting tool. Okay, so for example, okay, we can have here, okay, saya tunjuk dulu yang ni adalah one sample, one group sample. This is group number 2. The green one is group number 3 lah. So by having this group, this is also a gelatin. We have fish, bovine and porcine. So we, after carry out the cluster analysis, I try to support, to just confirm, does the variable, significant variable that we have selected in the PCA, tadi dalam PCA there is a significant factor loading, strong factor loading. We choose that strong factor loading and we try to group the gelatin, using cluster analysis. So we can still get 3 groups lah. So the yellow one, the green one can be porcine, bovine and fish lah. Okay, so number of intercept between the dotted horizontal and vertical line indicate number of group cluster. So kita tengok berapa banyak intercept dia. 1, 2, 3. Okay, so there are 3 groups sebab there are 3 intercept of horizontal and vertical line. With XLStat, you can let the software to create group clusters the observation, meaning that we will let the software to automatically create the group for us. Or else, kita pun, we can also decide, I want 3 group. So we just request the cluster analysis in the XLStat to make 3 groups according to the similar characteristic. So kita boleh push dia, the software, to get 3 groups, or we want the cluster analysis using its algorithm to create an automatic group. Let it be lah, macam tu lah. So that's another approach lah. Okay. So beside of the dendrogram, okay, yang ni dendrogram saya ulang balik, this is the dendrogram. So now we will get another plot, we call it a profile plot. So again, this is an example. We bring again the McDonald menus, and then we try to plot the McDonald menus lah using cluster analysis. Yeah, and then together with the 5 variables lah, 5 nutrient. So the profile plot indicate the distribution of variable for each group cluster. This profile plot, they will select or assist you to select which nutrient are the main contributor for that particular of group. So you can see the number 1, the red color, is McDonald menu with the high energy. Kenapa high energy? You can tengok dekat sini. Energy dia masih lagi tinggi dekat atas ni. High energy, protein, fat. Sebab dia masih lagi among those 3 group, it is the highest, saturated fat. And low carbohydrate. Sebab they are the lowest among these 3 group. Red is another group, blue is another group, yellow, green is another group lah. So we have 3 groups or 3 cluster. Group or cluster number 2 is the McDonald menus with an average high energy. Tengok energy, go back to energy high sebab dia dekat tengah-tengah lah, blue color. And low saturated fat because it has the lowest saturated fat. Okay. Group number 3 or cluster number 3 are the McDonald menus with average high carbohydrate sebab the highest carbohydrate among the 3, and low energy. Sekejap, mana energy? Protein and fat. Dan juga fat. So this is the profile plot that will assist us. Compared to the principal component analysis, they will tell us which variable characterize that particular grouping. Macam tadi dalam cluster, dalam PCA. But now they will inform which is the highest among the group lah. Okay. So up to that level, let's go to the last hands-on for today. Okay. Kita akan pergi ke sharing Excel, this one. Okay, now go to number 5, file number 5, name as cluster analysis. Boleh buka, open up that one. So MPCA tadi boleh tutup lah. Saya terbuka pula. Okay. Save. Sekejap ya. Okay. Sekejap, saya share. I share the analysis. So kita tak nak this one. Kita nak ni je. Okay. So again, in this cluster analysis file, so you can have, there are 3 sheets there. Okay, single McDonald's. This is the original data. variable transformation. So kita dah transform, we have to transform the data first, and then we are going to have a cluster analysis. Okay, but in the XLStat, they don't simply use the word cluster analysis, but they use the word of agglomerative hierarchical clustering, AHC. But the principle is cluster analysis lah. So macam mana nak buat? Sekejap saya tengok dulu dia punya ni. So we are still using the similar file, which is cluster menu. Okay, so open 5, number 5, cluster analysis, conduct transformations. We already conduct the transformation. Use the transformation data. Okay, choose analyzing data and click agglomerative hierarchical clustering, AHC. Okay, make sure to use agglomeration method, complete linkage and truncation, automatic entropy. Okay, so macam mana nak buat? Go to our XLStat, open up the XLStat icon. Okay, go to analyzing data and then click agglomerative hierarchical clustering, AHC. Okay, again, open up your XLStat, go to analyzing data, and then choose agglomerative hierarchical clustering. Kenapa ni? Ada problem pula. Saya tutup dulu. Okay, go to agglomerative hierarchical clustering. Alamak, kenapa dia ni invalid use of now ni? Sekejap ya, saya try buka lagi satu. Tak boleh lah, saya punya ada issue. Now is a very subtopic. Boleh. Cuba buka. Sekejap ya, saya punya ni ada isu sikit. Saya minta Azrini tolong sharekan dia punya tu screen. Try buka dulu. Kalau boleh, kita continue nak. Saya tukar tempat dengan Azrini kejap. Okay. Okay, so Azrini boleh bukakan XLStat tu, klik yang atas tu dulu, tunjukkan sikit. Okay, cancel dulu. Okay, go to XLStat, analyzing data and go to agglomerative hierarchical clustering AHC. Okay. Tolak tepi. Okay, for observation and variable table. Okay, so click that one untuk search energy up to saturated fat and then drag down to the lowest column. Okay, make sure you choose observation variable tables. Yeah. For proximity type, click dissimilarities and also Euclidean distance. We have lots of way of algorithm. Sometimes we can use lots of it. But for this workshop, we just use Euclidean distance. Click that one. Okay, for agglomeration method, maintain the Watts method. Yang ni boleh try lah. You can try at your home. Nak pakai different way to see the result lah. Okay. And then go ensure to column labels. And then for row labels, click column label and row labels. Okay, now click the McDonald's sample and drag down to the Sunday caramel. Okay, for options, click cluster rows. Cluster rows. Cluster rows, correct. Cluster rows. And then click truncation is automatic entropy. This is the one that I've been sharing. Kita allow them to do it automatically. Yeah. Entropy and then missing data. Click do not accept missing data and output. For output, just let it be. Okay, and then for charts, okay, click the last. Click everything, including the profile plot. Last kali. Okay, sorry. The dendrogram tu let it as vertical, and then click OK. Click continue. Okay, tak apa, boleh stop. Okay, let me share how the result looks like. Sebab dah ada kan senang sikit. Okay, so nampak Okay, so this is how the result looks like. Okay, again, this is summary statistic at the first place, which is the descriptive statistic. Again, boleh nampak, you can see any kita panggil apa, transform method, transform data will receive standard deviation of 1 and mean is 0 lah. Itu pen warna hitam sikit, warna merah. Okay, so for the rest of it, okay, this one proximity matrix. We want to check about this one, apa dia tulis kat sini, correlation between the McDonald's menu lah. Okay, this one we want to check is there any correlation between the McDonald's menu itself, and then the explanation is similar like correlation matrix in the PCA. Strong, which is having more than 0.7, macam tu lah, still similar. Okay, so based on the similarity, the cluster will be plot. Okay, and then this node statistic is the table that use show the data for the successive node in the dendrogram. The first node has an index which is the number of objects increased by 1. Hence it is easy to see at any time if an object or group objects is clustered and another object or group of object at level of new node in the dendrogram. So yang ni, by having this node, the algorithm will show us berapa banyak group yang dia boleh create lah. So starting like last one, they will create up to 25 node. They will create a 13 grouping, meaning the individual. So at 24 node, we can get 8. Dia baru groupkan for 8 McDonald's menu. At the node of 14, they start to group 2 menus. Macam tu lah. Okay. So this one similar lah. Okay. Copernic distance matrix. Ini apa pula? Okay. This CD measures the dendrogram height of at which the McDonald menus belong to the same cluster. Okay, they just want to show the dendrogram, the location of it lah. The higher the higher the height, so indicate is having a not similar characteristic. So again, this is more on calculation part on how to show the result lah. Okay, so this is the one that we are looking for actually. Daripada calculation tu, this is the one of the dendrogram. Okay, saya delete dulu. Okay, so you can see there are 3 groups produced. Yang pertama, tak kecil sangat. Okay, the first group is, we can see, okay, there are, how we identify 3 group, because there are 3 intersect between horizontal and vertical line. Okay, so the first group we see we have sundae chocolate, sundae strawberry, sundae caramel, pommes frites and apple pie. So kita nampakkan yang ni semua yang dekat dengan karbohidrat. And then second group we have cheeseburger, Big Mac, McFeast and quarter pounder with cheese. Okay, apa yang kita boleh find from here, nanti kita akan tengok. Group number 3 we have hamburger, fillet of fish, grilled chicken and McChicken. So this is the group lah. So that indicate there are some similarity related to the nutrient or nutrition that each menu have, that makes the menu be located together. Okay. Now the dendrogram is made into a simpler form. So dia terus buatlah 3 groups, C1, C2 and C3. Okay. And then we have this one ni tak ada apa. Okay, class centroid. This information indicate the central value of the nutrient in each group cluster. Ni just nak beritahu lah, just information. What are the middle value? And then this one, distance between the class centroid. This information tell us on the distance value between 2 groups. Kita ada 3 groups. So the group having higher value indicate they are having larger differences lah. Tapi yang ni kan they just nak share or tell us about the information related, mathematically proven. Okay, central objects. Central object is the information indicate which menu has been identified as central object. The table provide nutrient value for the menu. Okay, ni pun tak ada apa lah. Okay, now I just proceed. Okay, now we want to check in term of table. Yang ni boleh buat in term of table form. Which menu falls to that particular or their particular grouping. Okay, sama je sebenarnya. This is repeating of this dendrogram. Okay. Apa lagi? Okay, now result by object. Simplify information from the result by class. Ni pun sama. This information, they transform into this transformation. They just want to tell us which menu on which group or class. Okay, now profile plot. Baru you boleh nampak this profile plot. See, this profile plot is coming together with the dendrogram lah. Okay, so you boleh tahu which group. This one has been explained in the PowerPoint. So you can see on group 1, they are high in saturated fat, high in fat, but low in carbohydrate. Okay, so now we know why. Okay, and then okay, yang ni I just copy paste from the PCA result, and then we try to see how the grouping goes. Okay, profile plot explain the average nutrient for each group. This one, we need to investigate this result by comparing the profile plot. Kita comparekan this profile plot, dendrogram and biplot from the PCA result. Does it contradict the PCA? Now try to redo the cluster analysis by deciding more than 3 grouping clusters, for example 10 grouping clusters, then evaluate the results. Okay, boleh try lah kalau nak try. Okay, so how to try? Oh, kena bulan Azri ni buka balik. Okay, boleh share balik tak hari ni? Saya stop sharing. Just take over. Hijack hijack. Dah sudah. Okay, so cuba hari ni klik balik XLStat.
Jadi variables.
Klik balik yang tadi. Tak, pergi balik buat macam AHC tadi.
So yang ke variables transformation.
Tak, pergi balik dekat XLStat tu. XLStat. Type XLStat, klik, okay. Keluar tak? Tak nampak. XLStat. Itulah tak nampak. Tak keluar
Yang ini ni apa?
Keluar. Okay, go to XLStat. Macam biasa, analyzing data. Macam mana boleh nampak? Saya punya tak nampak. Saya tak nampak.
Tapi ni tu drop down tu tak nampak.
Can you click again, XLStat?
Nampak ni kena tekan analyze. Tekan increases ni.
Tak keluar. Cuba tutup balik sharing tu. Share balik. Keluar. Saya nak tengok yang klik XLStat. Baru keluar. Okay, go agglomerative hierarchical clustering. Okay, now go to options. Okay, on truncation, click entropy. Number of classes. Okay, sekejap ya. Can you try to click 10? Type 10 there.
10 to 10.
From 1 to 10. Okay, and then click OK. Continue. Saja, Y10, we just choose, we push the system to create 10 groups. Sekejap ya. Sekejap. Saya nak pergi buka sekejap. Sekejap ya. Workshop, multivariate. Mungkin ini boleh stop sharing. Okay. Nampak Okay, so this one similar with Azrini's done. Okay, so the first one that we make is we push the system to make truncation from 1 to 10 groups. Okay? So you can see that this is just one group. Everything is located to one group, so there's no profile plot being suggested. Now they move to two groups. Yeah. So in these two groups, you can see the profile plot is moving. We can know that first group having high protein and high energy and also high fat, and vice versa lah. Okay, now we go to classes number 3. So you can see we have the similar result in the first dendrogram. Yeah. Now we go to the fourth one. Now you can see in the fourth one, sundae caramel, sundae strawberry, sundae chocolate, pommes frites, and apple pie are going or are starting to differentiate, but not yet. However, you can see hamburger are now separated from fillet of fish, grilled chicken, and mac chicken, which indicate there is some variable being characterizing why hamburger is separated. So as you can see, it is falling down the or dragging down the what we call that one, the horizontal line. Yeah. So now we can have a 5 group. Sundae chocolate, sundae strawberry, sundae caramel, and pommes frites are separated now. Okay. While cheeseburger, McBurger, Big Mac, and McFeast, quarter pounder are beef grouping now. Hamburger are separated. Okay. So this is how the result if we push the system to have their own grouping. Okay. So now you can see this is the best result that reflects your profile plot. Why? Compare your result or this dendrogram with the profile plot from the biplot from the PCA. So you can take this result and then put it into your PCA. Put it into your PCA lah. Go back together. Boleh tengok sekejap. Copy. Okay, so we have 3 groups now. Sundae caramel semua dekat sini. Pommes frites. You boleh nampak dekat sini lah. Okay, you can see sundae caramel is one group, which is here. Pommes frites and apple pie is here. Cheeseburger, Big Mac, and McFeast, also quarter pounder, are here. Is it correct? Yes. Grilled chicken, mac chicken, and fillet of fish are different. This one grilled chicken, hamburger, fillet of fish. They are in the middle. So actually there are 1, 2, 3, 4, 5. 5 group is the best grouping to tell us which menu are having similar characteristic. So this is why we can use this cluster analysis to group our samples. So this one I just try to put up to 10. Can they relocate or we call it explain which menu are actually having a similar characteristic lah. So you can try this one about cluster analysis. So for cluster analysis, it is also recommended that if we want to support principal compound analysis, cluster analysis can become one of the two. Okay. Okay, so thank you, Azrini. I'm so sorry about this one. I'm not so sure why I have been error with this XLStat, but it's okay. So you just go back to the PowerPoint. Okay, So now we have conducted the cluster analysis, principal component analysis, and prerequisite of multivariate data analysis lah. Okay. So this is the end of day 1 workshop. We shall meet tomorrow at 1 p.m. Okay. So any questions so far?
From the chatbot, no, Dr. Shirwan.
Okay. So everyone, thank you again. I'm so sorry about the cluster part. Yeah. Perhaps I having issue. I hope that I need to restart the PC. Yeah, to have a proper installation of XLStat again. So if you have any question or I recommend that you can contact OPM me. Okay, and my recommendation for XLStat for the multivariate data analysis, you cannot simply excel or expert in one day. So by having these 2 topic or 3 topic that we have shared this morning until this 1 p.m. I also recommend that you can try rerun again the data set, and then so you can see what problem that you face, and then anything that you need to for me to explain tomorrow, we can proceed and have some discussion tomorrow as well. Okay, so that's all from me. Thank you again. Please come back tomorrow for us to complete with the 2 topics, which is the discriminant analysis and multiple linear regression. That's all from me. Assalamualaikum warahmatullahi wabarakatuh. Okay, back to you, Sister Alifah.
Okay, thank you, Dr. Shirwan, for today. And the rest, if you have a question regarding the software or whatever it is, you just can drop your question or anything in our WhatsApp group. So easier for us to communicate. So that's all from us. See you tomorrow, inshallah. Assalamualaikum.
Thank you.
Welcome.